All right, everybody. Hello, my name is Greg Dixon, and I am the chair of the Pacific Northwest section. I'd like to welcome you all here to our meeting, and thank you all for being here. We have a wonderful meeting organized and planned for you tonight, um, which is Rational Acoustics, Smart, the history, applications, and unusual case studies in the role of curiosity in audio, presented today by Michael Lawrence and Jamie Anderson. So again, thank you so much for being here. We're welcoming everyone here. Thank you for being with us today. I'd like to first of all thank Dan Mortensen, committee member of the Pacific Northwest AES section, for the meeting coordination today and helping us organize this meeting. Thank you so much, Dan. As I mentioned before, we use our real names in Zoom, so I'm going to just actually go over a few technical details. We use our real names, so if you can, please change your name to your real name. We'd appreciate that. During the talk, when Jamie and Michael begin, everybody should have their microphones muted, and just in general, if you're not talking, please help us out by muting your microphone. In addition, while the speakers are speaking and presenting tonight, we'd ask that you please mute your video as well, so that the video in Zoom can really focus on the presenters and the speakers that we're trying to pay attention to, like Jamie. So how do you participate? Well, there's still lots of awesome ways that you can participate, and I'll go over those. So if you want to ask questions, please don't blurt out your question as soon as it comes into your mind. If you could, please help us out by posting your questions into the chat. And our friend Jess Berg will be helping us with moderation tonight. And Jess will be taking your questions and fielding questions and passing them to Jamie and the other Michael and the other presenters tonight. So thanks to Jess for helping us with that. So again, if you have questions, please post them to the chat, and we'll make sure that the presenters get them. Jess may ask you, if it's a kind of complicated question, to say something. So if you ask a question, perhaps be prepared to open up your mic and to clarify or expand upon your question if you're asked. If for any reason throughout the meeting that your video happens to get muted by our hosts, it could have been inadvertent. We try not to make mistakes, but if it does happen, there's a chance that your video was on while we were trying to focus on the speaker's video. So if this happens and you're not able to open up your video later on for the intros, which I'll speak about in just a moment, let the hosts know, type into the chat, hey, I cannot unmute my video, and we'll do our best to help you unmute your video as soon as possible. So last thing in terms of technical details, after the presentations are over tonight, we like to do kind of a meet and greet and let people introduce themselves if they'd like. So please stay after the meeting if you want to introduce yourself and let us know a little bit about yourself. At that point in time, by all means, we would love to hear your voice and see your video if you would like. So please be aware that after the presentation, you'll have that opportunity. At this point in time, I'd like to pass the mic over to Dan, who will be talking a little bit about his initiative called Tea Time Topics. And Dan is also going to be helping us introduce Michael and Jamie. Thanks, Dan.
All right, thanks, Greg. Welcome, everybody. I'm going to put up a something to look at other than me. Oh, come on, there it is. I looked back in time over our section's meeting history, and thanks to Rick Chin, Gary Louie, and Dave Tosti Lane, we've got archives that go back to 1993 with summaries of every meeting. And I pulled up all of the FFT related meetings that we've got. And if you're interested in learning more about any of these, you can go to the website above, our website that I listed up at the top there, and then look in the archive sections and look by year, and then you've got the date so you could find any of these. So what I'm going to talk about while you're looking at that is the Tea Time Topics meetings that we're doing every Saturday afternoon in Seattle, Seattle time, 3:30, and we go till 7 o'clock roughly and talk about whatever subject are interested in. A lot of audio subjects. Although this last Saturday, Gordon McGregor from Scotland, who joins us every week, gave us a talk about the Royal Air Corps in World War I, eyes in the sky, and showed the development of the airplanes, the engines, the radio communication, cameras on airplanes. It was really fascinating. And everybody enjoyed it. It was fun to see all that stuff. There's a lot of history as part of this. And this Saturday, Michael Gray is going to give us the history of the Decca Tree microphone array system. And that's going to be number 49 in the series that we've been doing here since last May 27th in the pandemic. And you're all invited if you want to come. Send me a chat saying you want the URL, and I'll be happy to send it to you. I'll PM it to you tonight during the chat later. And so before I introduce the presenters and get going here, I wanted to also show you I'm going to get rid of this picture here.
Hey, Dan.
There's pardon me?
I wanted to say I forgot to announce one thing too. So after you're done with this, I'll need.
Why don't you do it now? Go ahead and do it now.
Okay. I wanted to let everybody know about our meeting next month, which I forgot to mention. Next month, our meeting is going to be on June 16th at this same time, 6 p.m. to 7:30. And we're going to have this meeting with Immersion Networks, who will be talking about a new mixing tool that they've been developing. It's going to be a great, exciting meeting. So please join us. That will be announced on our website soon. But the other important announcement that I needed to make was that next month is our election meeting. And we'll be holding our election next month. Please have a look at our website if you're interested in looking at the slate of candidates, as well if you want to reach out to the section chair if you're interested in running. Okay, thanks.
All right, thanks, Greg. So it's really fascinating to us, the worldwide reach that we have via Zoom, and it's fun seeing who you are. And I'm the guy who does the Eventbrite questionnaire and all of that, so I keep track of what all this is. So as of 4 o'clock today, there was 154, I think. I can't quite see that, it's behind my thing, signed up. And even though there's 87, 88 now, there was 154 who signed up. Of those 154, 102 said that they are AES members, which is 2/3 roughly of the signups, and that's unprecedented in any AES meeting we've ever had before. And I asked, how did you find out about this? 22 found out from a friend, 6 from an Eventbrite direct mail, 36 from Facebook. That's a huge number compared to normal. 26 from the national AES mailings, 43 from our local AES email, which is ordinarily the ordinary source. Then there was 14 from a variety of other sources. 6 of them had found out about it from 2 places. 62 are already on our email list. 22 do not want to be on our email list. What have we done wrong? Sorry. 70 though want to be on the email list, which is dynamite. And this is the great part, where you're all from. In the US state, Washington leads the way, of course, with 32, because that's where we are. Arizona 1, California 19, Colorado 2, Connecticut 1, Florida 4, Iowa 2. And I'm reading these off in case people from around the world don't know what these abbreviations are. Kansas 1, Massachusetts 2, Maryland 1, Maine 1, Minnesota 5, Missouri 2, Montana 2, North Carolina 2, Nevada 1, New York 2, Ohio 3, Oklahoma 1, Oregon 6, Pennsylvania 2, South Dakota 1, Tennessee 1, Texas 8, Virginia 2. And then look at the list of people from foreign countries who signed up here. Argentina 1, Brazil 8, Canada 11, with 4 provinces represented there. Chile 4, France 2, Germany 1, India 5, awesome. Indonesia 1, Israel 1, Japan 2, Latvia 1, Philippines 1, Poland 1, Singapore 1, Spain, UK 4, Vietnam, and unknown 1. So there was one, there's actually about a dozen since 4 p.m. who signed up, and I haven't incorporated that in. But as fun as it is to see that and know where you're from, it's even more fun to hear from you directly to say who you are and what your audio interest is. So I hope as many of you as can hang around afterwards and tell us what your connection to audio is. So without much further ado, I'm going to introduce Jamie Anderson, and just you can read their further bios on our website, but I'll just want to point out that Jamie has been part of FFT analysis in audio practically since the beginning. And it's really great to have you with us here today, Jamie. And Michael is in charge of the SPL part of Smaart, which is real interesting, and I'm hoping we get to do another meeting with Michael to talk about that part in the future, because that's important. And Bob Smith will provide some color commentary. You saw earlier that he's been part of our section on FFT meetings a bunch of times, and so it's great having Bob with us. And thanks to Jess for monitoring chat and passing on questions to the presenters as appropriate. So without any further ado, if you're not a presenter, please mute your video and your microphone, and welcome to Jamie and Michael.
Hey there. This is great. Thanks for having us here. Pretty amazing seeing 89 people have shown up. This is great. I'm so used to lately having 100 people sign up and 10 actually show up. It seems the standard in COVID days now. But anyway, I'm gonna start this off with a PowerPoint that I just made this last weekend for you guys. It's just made for this purpose. So consequently, I don't know how long it's going to take. I'm thinking that it's going to be about 20 minutes. But who knows, if you've ever sat through a class with me, I can go on and on. So hopefully I'm going to try and speed through it so we can get to some fun stuff. When we were talking about the subject here, we were talking about the history of Smaart, and it kind of parallels my history in audio. In fact, I've spent about 21 years of my life working on this project that is Smaart, and so I wanted to kind of give you a look at this from my perspective and what I went through in the pro sound, pro audio business, and kind of walk through some thoughts on that. And hopefully it will end my section quickly and we can jump off into Michael's mania and all that cool stuff and get into Bob's stuff. And this should be a good time. So I'm going to go and I'm going to share my screen and I'll give you a very simple, sparse PowerPoint, and I had to give it a silly little name. So I have my Smaart history, dual channel, FFT, and me. And so this is my background. I went to college for optical physics and electrical engineering back when control electronics wasn't about, controls wasn't about software really. It was actually about phase locked loops and all sorts of stuff like that. And then I went from undergrad, I went on to Yale Drama School for theater. and then on through audio. And so what I'm going to do, I did teach for a year at USC, but then I was at Meyer Sound for a lot of the 90s, an independent sound engineer, then worked for EAW. I'm going to cover all this as part of this whole thing. Just want to say you can find Rational Acoustics at www.rationalacoustics.com. You can get me at jamie@rationalacoustics.com. You can get Michael at rationalacoustics.com. You can get us both at support@rationalacoustics or training@rationalacoustics. So we'd love to hear from you. Probably the best email address for us is either training or support, because we're always monitoring those. Okay, so I just want to talk, we'll start back in the ancient times when dinosaurs ruled the planet and rock and roll shows were big and big blunderbusses of sound. The whole point here, the reason why I'm starting there is because I really became aware of pro audio in the 80s, going to rock concerts and different shows. I also was deep into theater at the time. But the whole point here is that the way the systems were back then, they tended to be single sources or big piles of speakers. What you've got here, you've got a picture in the lower left-hand corner is a Clare Brothers S4 system. The one up center is actually the system from Woodstock. Everybody knows that they got the Wall of Sound, Grateful Dead below that. And on the far right side, what you've got is the Showco Prism system. All of these things, the thing about these systems, was that they were relatively simple systems. I would say systems were simpler. There wasn't a lot of, you weren't talking about delay lines then. For equalizers, the equalizers were very simple tone controls or graphic EQs. The thing was that tuning these things was a relatively simple process. It really consisted of, in a lot of cases, just turning up your amplifiers to different levels. So maybe bringing your 15s or your 12s up to a certain level, and then you bring up your 2 inches, you bring up your mid-bends, you bring up your horns, you bring up your tweets, and you get the general tonal balance just by driving the amplifiers, turning them up and down. Any type of tuning, there was this great analyzer that we discovered in the 70s, 80s, which was the RTA. It's a brilliant piece. Its whole job is just to show you the frequency content of what you're listening to. And there was a really clever way of tuning a system, which was to put flat pink noise through the system and then adjust it till, because pink noise looks flat on an RTA, it sounds flat to us. And so you could adjust your graphic EQ to kind of tune the system there. Down on the right-hand side is a beloved device to a lot of us. It was an Ivy. It's a really cool, just handheld RTA down there, spectrum analyzer. And so this was actually the first analyzer that I ever used, was the Rane RE27, which it put all that stuff together. It could make pink noise, and it had little green, yellow, and red lights up top, and you adjusted your sliders, and you put pink noise through the system, and you played with the sliders till you got all the green lights lit up across, and there you had the system done. But as there was a basic concept here that was kind of out there, that it was that you could get loud sound or you could get quality, but you couldn't have both. And I think that's something that a lot of the companies, the people that we know in this industry, took exception to. And there was a lot of work done in the 70s and 80s and 90s to kind of prove that wrong, in improvements in equipment, improvements in PowerPoints, not PowerPoints like this presentation, but the amplifiers and the drivers and the cabinets design. All of a sudden you started going from having multiple cabinet systems to all in one. You had stuff like the MSL3 and the KF850 showing up. You had much more consistency. There we go. You had better consistency. You had better directivity. You started to get better tools, both parametric EQs and things like that, delay lines, all sorts of stuff. And also started to make use of distributed systems. And so there were a lot of problems that were being overcome, both with the limits of the equipment and the limits of the system designs. And as we started to do this to make our big systems better, we started to, the whole system alignment and tuning became a much more complex process. And here I've got a couple systems. This right here, this is a modern system. This is just, this is Metallica in a stadium, but just to point out that, of course, you've got delay systems, which are standard now, but I mean, delay lines weren't hanging around back then. You've even got subs on delays. You've got cardioid subarrays here, and throughout here, you've got infills and outfills and multiple systems. Instead of one blunderbuss of a pile of S4s or a Prism system, you have a lot of separated out systems. Down here, you have some front fill systems on this thrust. This right here is the Beyonce System. You can't really make out a lot of it, but it's exploded in the same way. You've got side shots, two front rigs right here. You've got delay systems here. You've got speakers along the front. In this system, this whole system is driven with the DMB, the array processing system. So every single driver in the system is driven by its own amp channel, its own DSP. So a pretty amazing thing. This is a different Metallica system with a sort of exploded center cluster and this subarray, which is a four-sided subarray that you can steer any which way, plus a subarray down at the bottom. Anyways, these are much more modern systems used for tackling these problems to be able to provide high quality sound at high levels. But of course, the tuning and alignment became much more of an issue. At first, with the RTA, you're able to ask a question. This is a key point in what we're talking about here today, is that analyzers are all about asking questions. And the RTA would give us kind of spectral information. It'd give us tonal information, but it didn't give us information about timing, phase, polarity, signal and noise, direct or reflected. These systems are basically, you're knitting a whole bunch of disparate elements together to make one big system. And in order to do that, you need to be not just looking at the frequency content or not just the tonal content, but you need to be looking at, phase, timing. Timing is part of the phase response, polarity. All these things are going to dictate how well a system's going to knit together. If you don't mind this stuff, then what you get is a big ball of confusion. And so it became important to expand and improve our analysis systems, because you used to be able to just tune by ear and maybe you had your RTA, but it became necessary to have a dual channel measurement system, something that could measure system response. And so here's the thing about at that time, end of the 80s, beginning of the 90s, dual channel measurement was, one, it was expensive. So the analyzers out there from B&K or HP are getting a TEF analyzer or any of these things. You're talking about like $12,000, $15,000 for the analyzer. Also, the practices of using them were very time prohibitive. They were very kind of laborious, methodical processes of using these systems, and certainly did not match the work process of live sound, which is, get it in, get it up, get it done. And so, they were complex. Very important thing to note here is that in a lot of cases, the people that are acting as road crew and engineers on these tours, there were a lot of really sharp, really intelligent people, but maybe not rigorously trained, maybe not deep in mathematics. a lot of really good intuitive engineers, but not guys that had studied transforms or anything like that. And so a lot of what was involved with these things might have been kind of foreign to them. And of course, they were expensive. I say that again because that is a barrier to entry for people to use them. And the analyzers, there weren't a lot out there. I mean, the RTAs, people could get their hands on them. They made a lot of sense. They were intuitive. But then when you have these other analyzers, they were scary. I mean, it was mad science, and they're hooking into your systems they weren't designed with probes. They weren't designed with classic audio connectors on them. So they didn't have 1/4-inch jacks really, or you'd have RCA, you'd have, alligator clips that you're clipping stuff. And these measurement systems were on the whole not really trusted or understood. So there didn't exist people weren't really embracing it, and because they were slow, they were a bother. And they were expensive. I'll say that one more time because that's real. And so come over here. These are just going through. This is the 2032 or 2034, the Buren Care analyzer. This is a little paper talking about using one in a concert. They also HP made analyzer. This is the 3562A. These were those analyzers out there. They doesn't look too cool. It looks kind of scary to me. And the thing about the displays were these things were tiny, and oftentimes they were showing their data on a linear scale, so that it's something that it was really learning to understand what was going on there. It was not intuitive for somebody to look over your shoulder and understand what the hell is going on there. So it really seemed like mad science. And with a lot of these guys, they didn't have a lot of calculation power, and so you ended up using multiple windows to knit together 120 to 20. So it wasn't something like you didn't even know necessarily what octave or what decade you were looking at. And so this was something that I think was frightening if you had your sound system that you were going to work on, and there were these mad scientists messing around with your system with this thing. You had to really trust what they're doing, and there was a lot of feeling that the people using these analyzers, I know that when I first got involved with SIM, people thought that I would make a change to the system and SIM would unmake the change. So it was making decisions. I would put a boost and it would take it out. And once you understand how this response analysis goes, you find out that it's doing nothing of the sort. All it's doing is you're taking the signal coming out of the mix, and you're looking at a microphone in the room, and you're just trying to determine how well that's being translated. So if you put in a boost, we're just looking to see that boost was translated. But there were a lot of circumstances, particularly early on, where when you were using an analyzer, sometimes you had to be scarce whenever the mixer was around, because they didn't want you messing with their system. Okay, so this is where I'm going to put in. This is where my story comes in. This is where I end up getting involved. I started, like I said, I started off as an engineer. I went to a school, WPI, here in Worcester. I might have been the one person from Connecticut, because I'm not located in Connecticut now. But at WPI, I was always in the theater, but I made money working for the local stagehands at it was called the Centrum. I don't know what it's called now. It's probably named after a bank or a hospital or something. But we used to load in all these bands, and they get to watch them put everything together and tune their systems. And I thought that was really cool. I got to tell you, I was actually interested in lights at the time, but I loved working with the equipment. And when we loaded in the Dead one time, Dan Healy and Don Pearson, we struck up a conversation with them, and they offered to power up their sound system and show us what they were doing. Now, everybody we had seen coming through to that point, everybody went through some type of noising process, and it was, or they'd sit there and they'd talk through a 58 or something, and they would noise the system that way. And what the guys were doing with ultrasound was just weird. They were using I think they were using the 2032 for their measurements, and they had some weird process that they were going through, and they were logging their EQ filters, and they were using these weird looking EQs with knobs instead of sliders, which to me was strange at that point. Okay, so they came through and they talked about everything that they were doing there, and it was pretty interesting because it seemed a lot more thought out than I was expecting from these hippies coming through. It's funny, I have the text of the whole speech that Dan Healy gave to us, that a friend of ours got the text for it, and it turns out a lot of the stuff he was saying would be crazy by our standards nowadays for system engineering, but it was pretty revolutionary then, and it kind of got my mind spinning. So anyway, I leave school, I go to graduate school, I decide to give into the dark side, and I become a sound guy, I become a sound designer. And immediately I run into the problem that I go into the studio, I make my tapes. We were cutting 1/4-inch tape at the time. And so I make my tapes, and then I go play them back in the theater, and it would sound nothing like it did in the studio, like it did in the theater. And in fact, when I pan it from left to right, it'd sound nothing like it did on the left side, on the right side. And of course, there's humming and buzzing and popping and all this stuff. And so I have a director telling me to turn the sound system off in between cues, which of course is horrible, because then you hear the sound system get turned on just before the sound cue kind of breaks it there. So anyway, I knew that I needed to get a handle on this and figure out why it didn't sound the same. And so I tracked down a friend who had one of those Rane 20, the RE27, borrowed that from him, and went along and did the basic tuning process with pink noise and the third octave EQ, and it was great. It helped so much, and I thought, I've got the solution to all my problems. And then I went on to work on a bunch of different shows, and we do stuff, everything from a little black box closet of a room to like a full size, the University Theater, about 1,000-seat theater. And so I noticed that while it helped every time, it didn't completely solve the problem. There were differences in every time I listened to it. And so it came time to choose a topic for a thesis. And I said, I'm kind of interested in what those guys were doing with the Grateful Dead. I want to get into measurement. And so I did system measurement and system optimization as my thesis. And I was lucky to track down some people. I got this guy named Bob McCarthy, who was with Meyer Sound, a guy named Ken Deloria, who was with Apogee, and a guy named Alexander Yulee Thornton, or Thorny. And all these guys, I got to be readers on the thesis, and I got to see what they were doing. And so after I graduated, because they were all from the Bay Area, they're all ex-McCune guys. And that seemed to me the hot spot. And so I did what I could to get myself out to the West Coast. And a year later, I was teaching at USC, but the riots came down and they launched Sim2, and I was invited to come up and work for Bob now that Sim2 had been released. And so I get up there and I get to play with Sim2. And now Sim was an interesting thing because it was, Meyer had been using a 2032, I think, for doing, it might have been using HP, but I think it was a 2032. But they, with what their process was Sim1, and so was Thorny was using a process like that for Pavarotti, and Ken Deloria was using it. They called it Preek, that Apogee was doing for tuning. So they were using these analyzers. But Meyer said, we want to build an analyzer that's actually for audio people, they didn't want to build it. They went to HP and B&K and said, can you build this? And their solution was just go buy 9 analyzers and strap them all together. So we didn't have military money or anything like that. So they decided to build it, and they built a thing that was Sim2, which was it had a 486 motherboard in it, but then 3 aerial DSP cards to do the calculations, and a delay board to do the necessary measurement delays, and that was what a Sim2 machine was. And so I got there in '92 when that got released. I think I have a picture right here. That's me at that time. This is I ended up doing work for ultrasound and for the Grateful Dead in the last couple years of the tour before Jerry passed away. So in '94, '95, I ended up doing system engineering work for them. This is the mix position from '93, but you can see there is the 2032 in the rack, and you notice you've got CP10 parametric EQs in here. This right here, this is actually at the Atlanta Olympics. This is a bomb went off just right over here. I was gone. I left before it had begun, but nobody got hurt in that. So that's a good thing. But that's the working at that rack, and you've got your pile of CP10 parametric EQs. And then this is working with the Sim machine at Telluride Bluegrass, and there you can see the rack of CP10s right there. The reason why the CP10 is the instrument of choice, and you can kind of see it in the measurement that our friend Mitch is pointing to right there. No, this isn't a stage photograph, but you're looking at the bumps in the system. The great thing about Telluride is it takes place in a canyon, a box canyon at like 9,000, 10,000 feet, and the weather will change on a dime there, where you'll be 80 degrees and sunny, and then you'll have horizontal sleet the next hour. And so with the weather changes, you saw all the bumps in the systems change. And so it was just a tuning rodeo. It was kind of fun. This up here is all of the delay lines, because this is a distributed system of things out there. And so this right here, it was an interesting thing, because even though I came from a theater background, the place where this type of measurement, the dual channel FFT measurement, really had gotten traction was in theater. And it was in theater because one, they had the time. Remember how I said it was time consuming, the process that was being used. And when you were tuning a theater setup, you would have entire night or multiple nights to tune the system. Secondly, it was preferred because the requirement in theater, the aesthetic, what they're looking for out of their system is something that is really accurate. You want to not believe that the speakers are on, or that you're not getting any coloration. And that just speaks to just a straight, flat tuning. Now, as most of us probably know, when in a rock and roll show or music show, oftentimes the way the system is tuned is not precisely flat. But it was something that this tuning process was really good at, was providing consistency across the theater. And so it became standard. The place where it really got traction was in the West End and on Broadway, and shows that could pay for that and provide the time. So I ended up spending time trying to get inroads into live sound and trying to work with people that were putting up these shows, and where the time constraints, it was much tighter. And you're trying to work with things on the fly. You're trying to, all unforeseen things happen. You're out in the weather, all sorts of things that you had to come up with ways of doing this that were not just this standard methodical, first this, then this, then this, then this. So it was a lot of fun, and I ended up doing Telluride Bluegrass each year. I ended up doing Montreux Jazz Festival each year. Got to see different how different mixers worked and how they reacted to the systems, and some people would come up and they wanted me not to touch anything, and others were curious about stuff. But it was a very interesting learning experience to see how mixers handled it, and the difference between when they trusted the system and when they didn't trust the system. It's a great little experiment to have a bunch of different acts and a bunch of different people play on the same system and watch how their reactions change the outcome of what you get. And I started to learn there that it was important to make sure that the people with their hands on the system were comfortable and you weren't scaring them, because that generally provided bad results. And that stuck with me throughout my entire career, is understanding that. And so the next slide is, this is our friend. This is my friend James, who's hacked a sim machine, and he's playing a racing game on it. It's a joke I use in class, because people play analyzers all the time like they're video games, and instead, they just, draw squiggly lines and stuff. So the thing was that about 1995, an interesting thing happened. The laptop computer, the personal computer, became strong enough to start running the FFTs in real time. It became possible to actually implement this analyzer, but implement it in software, and that was an amazing change right there. A guy named Sam Burkow and Thorny, same Thorny. They were going to get some aerial DSP engines to do the DSP, to do the FFT calculation, but they didn't show up. And so while they're waiting for it, they mocked up the analyzer in software, and lo and behold, it ran. And this was sort of the birth of Smaart, which system measurement, acoustic analysis, real-time tool. If you want to know where that came from, that's where that comes from. Interestingly enough, it was almost called CQAC, but it was not. And so they started this running. So the next year, they went around and they talked to a bunch of companies. They came up and this is the first time I had seen this. They had shown it to us at an NSCA. It was at that point, I thought it was a toy. It wasn't going to go anywhere. They went over to JBL. JBL was interested and signed a deal to distribute this program Smaart. And that right there is Smaart 1 from the JBL Smart Users Manual. And so that was the guy. It was designed to run on a 33 megahertz 486. It was with probably 16 megs of RAM, maybe. So then the next year, they came out with JBL Smart Pro. The pro about it was because that they added phase, because at the time he was just calculating the magnitude and the transfer function, and he took a lot of crap for not having a phase trace up there, and so they now with phase, and so that became JBL Smart Pro 2. And was in 97, I believe. And then the next year, at the end of the year, so at the end of 98, Sam wanted to actually sell. He didn't want to just stay in software design. He's an acoustician. That's his love. And he didn't want to be, saddled with running a software company. So he went to sell it, and a guy named Ken Berger at EAW jumped in and bought it. And so EAW purchased SIA software. And at that point in my career, I had been on the road with Katie Lang, and then after that with the Dave Matthews Band. But it was at that point in my life where it was time to get off the road and stay married. So at that point, Ken tracked me down when I was in Worcester. It's kind of funny that Worcester plays a role again in my career, but he tracked me down here and told me he had bought this company and could I come over and manage this thing called SIA software. So myself and my wife, who was the director of marketing at Meyer Sound at the time, we took jobs and moved to the East Coast. So at the beginning of 1999, and Smart Pro 3 came out, which was just incrementally better than Smart Pro 2. I wasn't a big fan of the interface, but I don't think anybody was. It was a very clunky interface, not feeling very powerful. We set to work, and we the next year in 2000, we released a thing called Smart Live 4. Oddly enough, this is a weird decision, but EAW owned it, but it was distributed as SIA Smart Live, but also under the brands JBL and Renkus. And I believe there might have been a Shure version as well. So that, talk about brand confusion, but we brought out Smart Live 4. We wanted to make it more like an instrument and less like a little tiny, Windows, whatever the program, that ugly program interface looked like before. So we brought out Smart Live 4. In Smart Live 4, we also introduced a concept, which was we had third-party device control. And so it started with a TC controlling it actually started in Smart Pro 3, being able to control a TC graphic EQ. But the whole idea was being able to control your equalizer and your system processor in the measurement environment. And so we ended up working with a lot of different manufacturers to build DLLs that could control those third-party products. And this actually worked well for a bunch of years. I know probably more than a few of you out there might have used these before. We ran into a wall in about 2004 when Lake came out with their processor, because that was something that we really couldn't copy into our environment. And so instead of putting the peanut butter in the chocolate, we decided to put the chocolate in the peanut butter, meaning that we built a way of exporting our data into their control environment instead of trying to control their product in our environment. And right here, in 2002, Smart Live 5 came out. This was one of my favorites. This was with us for a bunch of years, and this program got really deep. When we talk about weird applications, there are versions of Smart Live 5 that are in the Pacific Northwest that were running welding machines. And we can talk about that later, how and why that was done. But right here, you can see the control of the third-party device, the EQ centers, the high-pass filter right there. But this was Smart Live 5, and it was a pretty deep code base by that point. There were features inside of features inside of features here. And so this is something that was really had reached a mature point. It could do a lot of stuff. There was also a lot of weirdness, though, carried over from assumptions made years ago. It's one of those things that, when you're building software, sometimes a silly decision you make early on can haunt you for a long time. Additional projects that were happening in that time, we did Smart RTA, we did an IO unit. It was actually audio control from Mount Lake Terrace up there in Seattle, or in your area. I'm sure it's not actually called Seattle there. But they made our Smart IO, which was a dedicated IO piece. Also, we worked with Dolby, and we made a specific analyzer, a version of Smart 5 called AT5 Soft, which was a Dolby, the Dolby analyzer. We still keep a very strong relationship with Dolby to this day. They now are kind of standardized on using us, so they don't have their own special build anymore. And then, see, this is where we were purchased. EAW was purchased by Mackie, and Mackie ended up getting purchased by, or became Loud Technologies, and then they got bought by a company called Sun Capital Partners, which are not audiophiles. And even though the name makes them sound like nice people, they're just bankers pushing spreadsheets. And so the thing was that they hit a point, they did not like this whole idea that our software was in continual development. And up until this point, since the time that Sam brought that out showed it to JBL in 95, we had been in continuous development. So the entire time, the interface is refining and all that's happening. And we get to a point where we're going to release version 6. And what we had done when we do a new version, that's an opportunity to make some major changes. And the major changes that we made was to port it over to Mac. Everybody had been asking for a Mac version. And so we decided to develop in this thing called WX widgets. And we got to 6.0 for release. And generally you bring out, as quickly as possible, you want to get to the next version and then you build from there. Well, when we released it, they fired our programmer and said, nothing's happening from here. They moved me. I was still product manager for Smaart, but I became product manager for all of EAW. Calvert Dayton, who has been with Smaart the entire time, got moved over to run software development for all of EAW. Basically, they shut off Smaart at that point. So when version 6 came out, that's why there's the frowny face. Development just stopped right there. So about 2 years later, we left the people that were basically SIA software, myself, our programmer, Calvert, and my wife, who is the CEO of Rational Acoustics now. We all left and we started up a company we started up Rational Acoustics in 2008. And one of the first things we did actually was then put out a patch for EAW Smart so that it could run on I don't know what it was, Snow Badger, Snow Leopard. I don't know which version it was, but we put out a patch for that. But from the time that we left in 2008 until 2010, we were working on rebuilding the entire code base. So that the great thing is we weren't burdened by this code base that was at that point 15 years old. And it was a single-threaded monstrosity. And so this was our opportunity to go back and rebuild from scratch, which allowed us to do things like be much more multi-platform, be multi-engine. This is what became Smart 7. Then 3 years later, we came out with a thing called Smart DI, which was a streamlined interface. It's funny, there's got more stuff on the interface right here, but in fact, this is a more streamlined version. It doesn't have multi-engine type of things. And in 2016, we came out with DI2, and then in 2016, we came out with Smart V8, which is the current incarnation. Yes, we are in fact we're in the development process on V9 because we're kind of in a 6-year cycle, and we're in 2021. So it makes sense that we would want to be released, a year from now, if all goes well. Sooner if we can. Always want to go sooner. And then, of course, we've always been able to measure SPL as part of our interface from version 3. There's been the ability to calibrate and measure SPL, and that capability has grown a little bit by dribs and drabs as we went. And then about 3 years ago, the capabilities of our SPL measurement, monitoring, logging, all that just exploded. And we were lucky enough at that time to, as the feature set was exploding and we were going to bring out a standalone SPL product, we were lucky enough to find Michael, who we were looking at and trying to get to work with us as a general instructor, but he's been able to focus on this and take this really far. And so we kind of consider him our product manager for SPL. I mean, in general, he's a smart instructor and another educator. The thing is that what have I learned in all this time? Well, basically, education is critical. From the time that, when I was at Meyer, we put together education systems there that continued on. So teaching sim classes right up into the point where I joined EAW, at which point I was kind of persona non grata with Meyer at that point. But then I was teaching smart classes, and for most of my career, teaching has been a critical portion of this. One of the amazing things is that you're trying to go and teach some, some technical concepts to engineers that are brilliant. They really know what they're doing, but it's about translating that into a lexicon that they understand. They're not working with, they don't know what a derivative is, right? Or they don't know what a transform is necessarily. And so the thing is that all it's about is going through and putting it into context that they know. And what's amazing is the stuff that's come up. Remember how I said that the process was too laborious and too slow? That's gone now. This type of tool has been integrated into the main process for so many engineers out there. And they've come up, there are so many things in the Smart interface that have come from just users working with it. We have, well over 10,000 active users on the platform, and we have a really good support mechanism and training mechanism that we're able to learn from our users as much as they're able to learn from us. And so one of the things I learned is, system alignment is about asking questions, right? You're going in there and you're trying to get this equipment, you want to figure out what it's doing, and you're trying to get it to do what you want. You're the analyzer. You're the one making decisions, and you have an analyzer is just there to help you ask these questions and show you data. It's just a tool. There is no smarting a system. That's a stupid thing to say. I like that we own the trademark on smart. That's cool. But smarting a system is a total misnomer. It's like saying I had a carpenter come and bosh my house. It's just a tool that we're using. And the cool thing about it is it's an objective measure. It's repeatable. We get tired. It doesn't get tired, I think. But the thing is that it's a good tool to put in with the rest of your tools, like listening. And an RTA is a great tool. It's a useful tool. The transfer function measurement is a great tool. And so this is one of the things that we work on is trying to make sure that our users can understand what the tool can do. And we understand that great ideas come from everywhere. You'd be surprised some of the brilliant stuff that have come out of what you might consider, I don't know, uneducated or people that do not have a classical engineering type of background. That are absolutely brilliant once they get the language to be able to describe what they're doing. And I've got a couple of examples of that. I can let that go for a while because I've talked too much already. But the one thing that we've kind of found, and this is something that struck me early on, when people come to class, and I would see, thousands of students over the course of my teaching. You never know. You would say you never know who's going to be successful at using this tool, but you do. You know almost right away when the person that is there learning the tool is actively inquisitive and interested in what they're doing. I get a lot of people that come in that want to be trained to use this tool, like this is going to be the substitute for understanding how sound systems work. And this is not, this is something like they feel that they can come and learn smart, and this is going to be a shortcut to being a great system engineer. Where instead, this type of tool is a force multiplier. It's going to take what you're able to do. It's going to expand your capabilities. But if you don't know what you're doing or you don't care, and it's a weird thing, but I think a lot of us are here because we just find this stuff really interesting. I always tell people, if you find the idea of loading firmware into amplifiers with a 6-pack of beer at 10 o'clock at night, if you think that sounds like a good evening well spent, then you're a geek like us. I mean, we just love you love the equipment. You're really inquisitive, and if you have that desire to do it, then that's what you need. It's when people try and let an analyzer, which is dumb, try and have the analyzer do the thinking for you. That's what you get is you get dead, dull, dumb systems. And anyway, so what I'm going to do is I'm going to stop my sharing right here. And hopefully that made sense to you guys. And I'm definitely, I've got some fun examples, but seeing as it's 10 o'clock here, and it's time for Michael, and so I think I'll just hand it over to you right now. How's that?
There's one question there for you.
Oh,
that I think
what is it?
Okay, just as I can read it. It says, please elaborate on significance of SPL, especially in distinction against FFT, frequency measurement.
Okay, so here's something. This bugged the hell out of me. And we're not. I'll answer your question in just a second. But it's saying, it's almost like saying, are you going to use an equalizer or are you going to use digital? Right? Because it's not FFT or it's the people quite often will use the term FFT to mean a transfer function analyzer, a dual channel analyzer. Whereas an FFT, a fast Fourier transform, its job is to take a spectrum. You take a chunk of a wave in time domain, because it's a transform. A transform just takes data in one domain, like amplitude versus time, and it's going to give you amplitude versus frequency. So it's going to give you the complex spectra. So you take a chunk of a wave, it gives you that. And in fact, you can do the IFT, so you can go backwards from frequency domain to time domain. It's just the way of transforming it. So if you use two of those guys, input signal, output signal, and then you compare them in a transfer function, then you get the system response. But it's just been sort of lazy, lazy lexicon. But basically, people will use FFT to mean a transfer function analyzer, and then you've got a spectrum analyzer. Well, our spectrum analyzer is fueled by an FFT. We run an FFT to get the spectral content of the signal. SPL is a measurement that predominantly is a broadband measurement. It's not completely, but the whole point is it's just saying, how loud is it? And there's a bunch of different ways to ask that question. And there's a bunch of ways to say, are we looking at RMS? Are we looking at peak? Are we looking at average over time? That this is something that Michael has become an expert at explaining. The thing is that the FFT generally, when you're doing an SPL measurement, you're not going into frequency domain. So you're taking your data, but you're calculating it right there in the time domain. And so there's ways. The whole concept here is there are ways of looking at data, and this is a really powerful measurement concept where you can look at stuff one way, you can look at it another way, and sometimes what you're looking for is obvious in one domain or in another, so that you can say we have A weighting filters, which is providing a weight to the spectral content of the data. But you don't have to take it into frequency domain to apply the weighting factor. You can just use a time domain filter and weight it in time domain, and you're taking the value of the level of the signal. Just like if you look at an input meter is sitting there in time domain, just telling you how big it is. So in that, I think the question is the thing about the FFT, or the thing about the SPL, is that with the SPL measurement, you have to be calibrated for SPL. It's calibrated to a real pressure level, whereas a lot of the work we do in system alignment and system work, it's comparative. So it's in versus out. We're not asking how much 1K energy is coming out of the system. We're asking how much 1K is coming out relative to how much went in. So we're asking, what is our system doing to the signal passing through it? Whereas SPL is, how loud is it? And more so, is this going to hurt me? Did that help?
That was brilliant. Thank you so much.
Oh, thanks, sir.
We had one more question from Mike Goodrow. Does your current system incorporate control of other equipment, such as equalizers?
We don't anymore, just because we found that once we started to make our data available for other products, like there's a bunch. JBL does stuff, Apex, the PowerSoft, a bunch of companies. What they do is we have an API, and they extract our measurement data into their control environment, because it makes a lot more sense. These control environments are so much more sophisticated now. They can do so much. And when you're taking a measurement, once you've got it set up to get the data, you really don't need to do a lot of control in that. You really want to have the measurement data in your control environment. And so we had to do this back when we were doing our DLLs in Smart Live, and we ran into I'm not sure how well you guys know this product, but it was called the Lake Contour Processor, or the Claire Contour Processor, and then they got sold to TC and Lab Group, but anyway, this was something where we really couldn't reproduce their control environment in Smart Live. So we figured out a way of pulling our data out so that they could extract it. And that process was really painful. So in 2008, when we left and we got to rebuild Smart from the ground up, we built inherent into the Smart code base is the ability to go in and pull data out, so that you can very easily, if you're a programmer and you want to build a program that accesses Smart data, just give us a shout, and you sign some documents. You don't have to pay any money, and you can learn how to use our API to pull data out. But that's what people prefer to do now. I mean, again, before, back in 2005, 2006, 2007, when we were doing this, the programming departments at most of these companies were small. So they were utilizing our programming resources to get their interfaces. Now they've got people doing programming, so it's pretty damn easy for them just to access our data. It's made to be gobbled up.
Awesome. Thank you. There's one more question from Katie Gray. She really wanted to hear about the welding machines.
Okay. And then we're on to Michael, and I'm not going away. Here's the welding machines. So someplace up near you guys. It might be in Oregon though, which is nearer to you than I am. But basically I don't know how they heard of us, and I believe how they heard of us was that a air conditioning manufacturer named Trane, HVAC guys, they used the spectrograph in Smart for spotting resonances, right, in their ducting and things like that. So that's a different use of it. But basically, they wanted to automate. There was this process, and I apologize, I'm not a welder. I can lay down a pretty good TIG bead, but basically, what they were doing was they were doing this welding process, this deep block welding, where the people would have to sit there and zap this block of metal, this big block of metal, for like 10 minutes. I mean, just this long period of time, and they'd have to stand there, and it was hot, and it was just a pain in the ass just to get it ready to go to the step that they needed to do. And they wanted to automate it. And so they asked all the guys on the welding line and on the production line, they said, how do you know when it's time to go to the next step? And they just said, it just sounds right. And then they cooked and said, maybe we could help them identify the sound of it. And so they came to us, and we said, I guess this would work. So we did this experiment where they recorded about 10 minutes of welding noise, and then they had all their welders come out, and they would say, they'd listen to it, and they'd say, right here, and everybody pretty much agreed that about like 8 minutes and 32 seconds, the process was ready to go to the next step. And then we just sat there and on the spectrum analyzer, we watched the spectrum of the welding noise, and it was very boring 10 minutes to listen to it. But what you saw was 120 hertz and its harmonics slowly creep out of the noise floor until it became dominant. And you could hear that that's what was going on. And so what we did is we built in a function into Smart Live 5 called a power comparator. And the power comparator, you could basically take the power in any 24th octave bin, right? So that we've already got the energy grouped into 24th octaves. And so in any 24th octave bin, you could sum up the power and compare it to any other 24th octave bins. Now, why would we do this? Well, we try not to do one-off features, but we still had to do a harmonic distortion measurement. And a harmonic distortion measurement, you're comparing the power in the fundamental to the power in the first 9 harmonics. So what we were doing was we were making the power comparator so that the harmonic distortion measurement was just a special case of that. And the cool thing was that they paid us a chunk of money, so they paid for the development time, and that was a win-win. That was a win-win right there. And so this power comparator is one of the many features that is buried in Smart Live 5. We haven't used it since, but to my knowledge, they maybe had that recreated or something like that. But it was still going. This was 2005, so they could still be using those, and we would have it just calculate a percentage number, and then they could read that percentage number with a little stream. They could pick that number out of the software, and so that's what that was. And it all keyed off of, I can hear this. Well, if you can hear it, the measurement that best corresponds with hearing is the spectrum, the RTA. Because its whole job is to take a signal and show you the grouping of that energy, the way your hearing mechanism groups that energy. So, did that go?
Yeah, thank you. There's a couple more questions now. Do you want to take them now, or do you want to
No.
hold off?
I'm gonna go get it. I'm gonna get a drink of water, and Michael's gonna talk, and I bet you he can take some of these questions as well. And then once I get a drink of water, I'll be right back and clue in.
Sounds good. I'll keep them all in a list, so we've got them.
Thanks. Thank you.
Thanks, Jamie.
I can answer Joseph's question. Yeah, as an individual, you absolutely can get the documentation. It's open to anybody. All you need to do is email support@Rational Acoustics, and they'll get it sent over to you. So, okay. All right. So we've talked about analyzers all night, and what I want to talk about is the why. And I also I'm going to rock the boat a little bit, but I love seeing people's faces. So if you want to hang out, turn your camera on, you're certainly welcome to do so. Then I can see how bad my jokes are in real time. So an analyzer, as Jamie said, is a force multiplier. It's a tool, right? A tool for answering our own questions. And so to me, this really strikes at the heart of what we're talking about when we talk about audio engineering. And so I will see if we can get this working here. There we go. Okay. So what do I mean by that? We're talking about the art of asking, I call it. And what's the role of curiosity in audio? And how does this affect what we do? When you want to take a measurement of something, we're looking for an answer. And so that has to start with a question. So we're talking about asking questions. So Pat Brown told me this a couple of years ago, and I think it's fantastic, and I use it all the time. There are 2 types of people on the internet: those who Google and those who create the stuff that gets Googled. And I just think this is such a great little tidbit. And it kind of doesn't work when you're talking to a group of people from the Audio Engineering Society. But when I say this to college classes, I say, they're college audio program students. And I say, do you consider yourself an audio engineer? And usually like 20% of the hands will go up. because there's a lot of debate. I'm sure we've all seen these debates on Facebook about, am I an engineer? Do I have to be certified in something? Do I need a degree? And what qualifies you as an engineer? And for a student sitting in a class and looking at material on a screen, it's very easy to say, like, yes, it's a noun. I'm studying this. It's something that you learn. It's very passive. I'm watching the professor. I'm looking at the PowerPoints. I would like to posit that it is a verb, right? It ends in ing, the gerund form, the present progressive. So maybe it's something that you do. Maybe this is a process that we all participate in. So I'm not going to ask a bunch of people from the audio engineering society if they consider themselves engineers, but the point is, I just want to kind of tickle your perspective a little bit on this. And so this is an example of what I'm talking about. We've all seen these things. We've all probably got one of these in our kit somewhere. I have about 15 of them in a basket in my basement. And so we've all picked this thing up and said, wow, hey, this, whatever this is, $25 plastic thing. Can I trust this? Can I trust the data that it spits out? And so I would ask the room full of students, how do you think, if you want to know, if your question is, can I trust this device? How might you go about answering that question? And they all say, oh, well, you can send it off to a lab and have it tested. And that's true. Or you can check it against a calibrator. And that's also true. But what if you don't have those resources? What if you don't have an SPL calibrator lying around? You're not going to send it to a lab. There's one really easy way to tell how much faith we should put in this thing, and that's get more than one of them, right? So you line them all up and they all give you a different answer. And okay, I know very quickly how much faith I should put in the data that this thing produces. So there's the old joke, if you have one SPL meter, you know exactly what the level is. And if you have more than one, you have no idea, right? But the point is, I'm not here tonight to talk about SPL meters. I think we'll be back hopefully another time to do that. The point is that we can come up with and institute an experiment on our own without having access to laboratory grade conditions that can still give us interesting and useful information about our question. And that is something that takes a little bit of mindset to get used to. This is something that these two gentlemen here have been hugely transformative, both in my understanding of this type of work and also just kind of how the industry views this stuff. Dave Ratt, you may know him as the front of house engineer for the Red Hot Chili Peppers, Audio Slave, Soundgarden, founder of Rat Sound, and Ethan Weiner on the right with his cat. I think that's Bear. He has 4 cats now. This idea about a relative test, a comparative test about, hey, if you're interested in something, go find out. Dave used to work for Mattel, the toy company, before he worked in pro audio. And he told a story about sitting in a conference room with a bunch of executives, and they've got this new toy, and the meeting is it possible that we shouldn't give this to kids? If it were dropped, could a piece come off and be dangerous? And Dave said, well, they were sitting around discussing what might happen if it were dropped. I would go out in the parking lot and drop it and see what happened, right? And so there's just a fundamental difference in philosophy here. And that's something that Ethan Weiner, for those of you familiar with his work, he has a book called The Audio Expert. He gave a absolutely fiery 2009 workshop called the Audio Myths Workshop, where he kind of really dug into this. And the whole idea is that if you have a question, think about how you could figure it out for yourself rather than having to appeal to another person or authority to get the information. And I'm absolutely not saying don't read books. I'm absolutely not saying don't go ask people on forums, but I'm saying don't let those be a substitute for trying to answer your own question and be an active participant in engineering. Okay. So, Dave, before he was with Mattel, he worked in a military application where they were testing missiles. And his job was to make sure that the missile was safe. And so they would put it in an oven and heat it up, and then they would shake it and they would drop it, and they'd do all these things to missiles. And so, by comparison, no, I'm not really scared about maybe breaking the SPL meter or what might happen to the microphone. And so that's why Dave's got this kind of fearless approach. But, this whole thing about audio is the worst that happens is it doesn't work and you put it back before, right? So, we can get our hands dirty with this stuff. And so what I want to talk about is a relative test. It's a very simple idea. And we are just talking about not being in a laboratory environment where we can remove all the variables, but let's just isolate them and only change one at a time. And I'm going to show you how powerful of a technique this is and what a really cool, actionable way this is to investigate claims. Okay. So here's a really basic one. I have 4 measurement mics here. Maybe I dropped one and I want to know if it's broken or not. And so what do I have is 4 measurement mics here. They're all within the same, golf ball sized area of space. I have 4 transfer function measurements, and I lay the traces on top of each other. And what we can see is these tell us basically the same story. Once it's when you get up above 4K up here, that's where we start to get a little bit difference, but we're still talking a handful of dB, right? You know, that's kind of that's where the difference comes in with these things. And so if I said, gee, I dropped my mic, now I have confidence that no, it's not broken, it's working just fine. I didn't have to send it out to a lab and measure it. You can see the absolutely horrible response here. It's anything but flat. That's a terrible speaker. My office is really reflective. There's stuff coming in all over the place. So I don't need lab condition to say, is this mic broken? I just need to compare it to other mics and see if it matches or not. Right. So this is a relative test. This is a good thing to do if you own measurement mics. It's a good thing to do once in a while. And weed out any, and typically, by the way, when these things are broken, they're really broken. So, you know, that's where you see it. This is 4 mics from 4 different manufacturers with no correction files loaded, by the way. So just for kind of an order of magnitude thing, you know, I've seen people get really worried about not having the correction file. And we're talking about in the type of work that we typically do in a live venue, the difference with or without the correction file, it's going to be smaller than the difference if you just move the mic over 2 feet and take another measurement, because we're not in a lab, we're in an acoustic environment. If you work in a lab, that's a different conversation, right? But this isn't anything to be scared of. And this is a test that anybody can do if they're wondering, gee, do I need my correction files? I don't know, find out, right? So this is why we have an analyzer. It's a tool to answer our questions. And you have to start with a question, and then you think, well, how might I answer that? And you know, Smaart is an example of a program that has a huge tool set for you to be able to answer questions like this. How about this one? Hey, I left my measurement mic in the car overnight and it froze. Is it damaged? Do I need to throw it out? I've heard that one. There's endless debates about this one on forums all over the place, and a ton of mythology about this stuff. I put one in the freezer to find out. And I think that's kind of interesting because there's nothing really special about me putting one in the freezer. Anybody could have put one in the freezer, but instead most of us chose to postulate and instead of actually finding out. So I put one in the freezer and then I took it out and I just kept taking measurements as it warmed up. And by the way, we're zoomed in really, this is 1 dB on the vertical axis here. So yes, there is a change in the sensitivity as the mic warms up over the course of 15 minutes. It's absolutely tiny. We're talking about a half a dB from literally just came out of the freezer to room temperature. So the thing is, you know, I'm not going to worry about this. And how long do I need to let it kind of sit at room temperature? Probably by the time you're done setting your rig up, it's fine. It's absolutely not broken. This is absolutely not a game changer. This is not going to cause people to ask for refunds because the system was tuned horribly. Okay. So again, with all of these things, it's not really about the answer that you get. I'm not here tonight to talk about measurement mics and why you should put them in the freezer, right? It's the process. It's about wondering what happens and then doing something to answer that question for yourself. That's the theme that we're talking about here. I have some custom molded Westone ER15 musicians earplugs. I think they're really fantastic. I wear them all the time if I have to mix. And again, another thing that people talk about, how much better they are than foamies, flatter response and this and that. And so my question for myself was, okay, when they say the response is flat, what does that mean compared to the foamies? And my other question was, I actually put them through the wash. I left them in the back pocket of my pants. Are they ruined? Are they still doing what they were supposed to do? Right. So this might seem like a tough one to test without, again, shipping them back to the manufacturer. So what I did is I got a pair of headphones and I put them on my head and I plugged them into my digital mixer and I used the tone generator on my mixer. And what I did is I would play myself a sine wave at, you know, kind of your ISO octavand centers, right? 125, 250, 500, all the way up. And I would turn the generator down until I couldn't hear it anymore. And I would write whatever level that was, negative 36 or whatever, right? And then I put foamies in and did the same test. So everyone says, well, what about the response to your headphones? It has nothing to do with the response of the headphones because it's not a variable that's changing. The only thing that changes was one I was wearing the earplugs and with one I wasn't. And then I did the same test again with my custom molded plugs. So all we're measuring is how much do they increase the attenuation over wearing no earplugs? You know, how much sooner could I not hear that tone anymore? And if you do that on octave bands, you get a nice little frequency response chart. I did it twice. The other thing this tells me is that the way that we put foamies in really has a big effect on the amount of attenuation that they supply. And we all know this. The other thing to take away from this, I think, is that when you look at the package and it says 32 dB of noise reduction, that is a gross oversimplification, because at some frequencies it's 10 and at some frequencies it's 55. So like most one number ratings in audio, you should be suspicious of it because it probably varies over frequency. But, you know, this is, again, it's not really about the result. It's about, I was able to get this without leaving my living room. Okay. Here's a fun one. We have all had the spectrum analyzer on our iPhone. If you don't, you should probably download one. They're kind of fun to play with. And so the question is, should I trust this? I see people going out and trying to, like, you know, measure sound systems with it. That I probably wouldn't do, because if we put aside for a second the discussions about the mic that's in the device and what is the response of the mic in the device, and there's a lot of concerns there. But what I did with this is just played pink noise through a speaker and held my phone out and used the voice memo recorder and recorded that pink noise back in a bunch of different orientations, facing the speaker, flat, sideways, facing away. And then I took those files back into Smaart and ran them through the RTA. And so what we've isolated here is the effect that phone orientation has on the frequency response of what the microphone's hearing. So I don't even really want to start talking about the response of the device that's built into your microphone and whether or not you calibrate it and all that. Just based on how you hold it, you're causing a 14 dB swing in the high frequencies. It's, you know, it's only around 5K, which doesn't matter to anybody. At least it's not an important frequency range. So the point is, this is something that I think we don't think about because we get all caught up on, like, you know, I calibrated my iPhone thing, and yeah, but you know, this is why measurement mics are tiny and we hang them out in space so they're not near anything. The fact that your phone is a boundary causes this effect. And what's interesting is I repeated this with an iPad. And the difference, and you see that we're kind of pretty much getting the same answer below 1K all the way down. If you do this with an iPad, the area of like really big variation moves down in frequency. It extends to a lower frequency because the iPad is a larger boundary, and so presents, you know, a meaningful boundary to longer wavelengths, which is kind of interesting, right? So this is sort of the you know, the Heisenberg uncertainty principle here, you know, is or the cat, Schrodinger's cat, right? Is it dead or alive? So like literally the way that you choose to measure this with your phone is going to affect the answer that you get. Kind of interesting, right? I hope that my point is starting to come across, right? Because we all have wondered about these things, and we like to see forum threads about these things and talk to our friends about these things. And very few people actually say, wait, we could answer this for ourselves. So I guess what I'd like to do tonight is nothing else, just kind of plant that seed and inspire people to, you know, kind of go mess around with this stuff. And if it's a terrible failure, then, you know, that's fine. Nothing happened. You don't turn into a pillar of salt, right? This has been a really interesting one. A lot of mix engineers like to talk about. I love the EQs on the Yamaha. Or I hate the EQs on the Digico or this or that. In certain consoles, the EQs sound sweeter. And this is interesting. I mean, if you understand the math of how those filter shapes are made, that statement stops making as much sense, right? And so what I did is I got access to 3 different consoles, and I put in the same EQ parameters, same frequencies, same bandwidths, and same gains. And what you see is that generates 3 different curves. And this is why people say that the EQs sound different to them, because they are different, right? So if you put the same parameters in 3 different consoles, they sound different. Obviously, these 3 things aren't going to sound the same. Now, the funny thing is, if you put different parameters in each console until the responses themselves match, now, of course, that's going to not sound different anymore because it's the same response. So this is a disconnect between what our ears are telling us and what the parameters on the console are, how they calculate their filter cues. You know, there's a rain note on kind of why this happens, but the point is, it's not that someone's got better magical musical EQs. It's that literally that their definitions are different, right? So they sound different because they're not producing the same response. This is a really cool one. I own a Midas console, the Pro Series. Everyone says, oh, they're great. You don't need as much EQ as you do on other desks. I've heard that over and over again. I see some people nodding that they've heard that as well. And this is why people feel that way. First of all, the Midas Pro Series EQ doesn't ever show you the combined response like most consoles. They only show you the individual filters. They want it to feel like it's analog. That's cool. It makes sense. I get it. The EQ screen on the console itself is really, really small. It's like the size of a business card. So you don't see this big full screen EQ curve like you do on most other consoles. And the first vertical division down here on this graph is -12. Or on most consoles, it's -3, -4, -6, something like that. So you're like, oh, I'm not even down to the first division on the graph yet. You've put -10 dB in. That's a pretty sizable cut, but it doesn't look like it on the screen. And so that's where this idea of I don't need as much EQ on this desk as I do on other desks as they're better. They're not better. They're just showing it to you differently, right? So they're kind of recalibrating that relationship between what you're hearing and what your eyes are telling you. I don't have a point. It's just interesting. Okay, so my buddy called me up a couple months ago, and it was last fall. And he said, hey, man, I'm going down to do this big drive-in thing in Austin, Texas. And he said, I've never thought about mixing for people listening inside of vehicles before. And he says, there any data on what happens to the response of a sound system if you're listening to it from inside a vehicle? And I said, no, I don't think there's any data that I'm aware of, but I said it shouldn't be that difficult to measure. And then there was this kind of idea floating around. I don't know if anybody saw it. It was coming on the forums, but it said like, hey, you should open your roof hatch if you have a sunroof or a moonroof, or you open your rear tailgate up, and it'll help the sound go through your car better for the people around you, right? So I kind of liked the social responsibility aspect of this and like be a good neighbor. And I really wanted that to be true. And like, we're all in this together, even though we're in our different cars. And I was like, wow, that's really cool, right? But is it true? So it shouldn't be that hard to test. We actually built a fake drive-in concert out behind the shop, and my buddy brought his car over and I brought my car over, and we set up a rig and we put mics inside the vehicles, and we tried absolutely every configuration of one window down, two windows down, all four windows down, doors open, trunk open, moonroom open. And what we found out is basically nothing makes a difference at all to the response that's inside the car. And, you know, is there a car parked next to you? Are there windows down? Or, you know, can you do anything to affect it for your neighbors? And the answer was no, not really. This, again, is a comparative measurement. The black was what the system was doing without any cars in place. And then when you put that mic inside a vehicle in the same spot, obviously we have attenuation. That's to be expected. It's actually kind of a more broadband attenuation than I would have expected. I would have thought you would have basically had a low pass filter and removed all your highs, but it was really more like a 6 dB high shelf. So it's not super drastic. So the best thing I can tell you is maybe mix a little bit brighter than you would otherwise. But the interesting thing is when you're listening inside the car, you don't really localize in front of you because the glass blocks the direct sound. So it's kind of like this ambient thing. And for whatever reason, it doesn't sound muffled. Like there's this kind of weird perceptual brightness to it. And I don't know why that is, but you know, unfortunately, you know, you can't really do anything to help out your neighbor's experience at the concert. What we found is as long as you have at least one window down, you know, kind of beyond that, you're not really going to do all that much for yourself, and you're not really going to do anything for your neighbor. But again, do you want to postulate about it? I thought it'd be kind of fun to measure, so we did. Okay, and I said this before, I don't want my point to be misinterpreted, right? This is not about the data. This is not look at all the results of the experiments I've done. That's not why we're here. They're all on my website. If you care, you can go look, right? There was a discussion on the live sound subreddit a while ago, and it was about EQing to get rid of feedback, right? And I prefer to use a narrow parametric cut rather than a graphic EQ because the narrow parametric cut does less collateral damage. You're going after a narrowband phenomenon, right? It's a sine wave. And so I don't want to take a huge chunk out of my spectrum. So the red here is if you take your 1K filter on your graphic EQ and cut it to -12, you can see I'm really taking a lot more energy out than if I do a -12 dB cut with a parametric EQ set all the way as narrow as it goes on a console. And so the difference here in between these two curves, that is the energy, that's less collateral damage that you can do to your mix. I find that to be quite audible. That big chunk, that's a third of an octave wide. That's a C to an F on a piano, right? That's a good amount of energy there. So the problem is, when I posted this, everyone said, hey, do this graphic EQ, do that graphic EQ. What about the ones on this console? I'm not here to measure EQs for you. That's like the opposite of what I wanted. What I wanted was to say, this is a question you can answer for yourself. If you have some EQs on your console, like okay, the Behringer X32, there's two different types of EQs on that desk. There's the GEQ and the TEQ. They're two different rack graphic type EQs. They make different shapes. What's the difference? You can answer that for yourself, right? And so this is not about the data that I have gathered as a result of doing this. It's about your ability to answer your own question. And so that's kind of where we come back to the analyzer and all this. Is that's a tool that plays a really important role. It's a microscope for audio, right? It allows us to kind of get under the hood of these things. And so, we all have smartphones that have spectrum analyzers, and there's Smart, and there's Systune, and there's Open Sound Meter, and there's Room EQ, and there's so many tools out there that you can use to answer questions. My first foray into audio measurement was actually Room EQ Wizard running on my dad's work laptop and the USB vocal mic that comes with Rock Band 2, right? Which is awesome because it has a built-in audio interface. So you plug that thing into your computer, it shows up as a USB class compliant device, and it was meant to be plugged into an Xbox or a Wii or whatever, but guess what? Room EQ Wizard will see it. And so based on that rig, which I don't encourage anyone to go and use as their go-to measurement rig for obvious reasons, I was able to measure a Mackie subwoofer that we had at the shop and find out there's a switch on the back of that subwoofer that says phase. One might assume based on that it inverts the polarity of the subwoofer, and it actually doesn't, right? Because I took two measurements and they were the same. What that actually does is inverts the polarity of the high pass output onto the sub that's going to go to the top. So I think they should have probably labeled that more clearly. But the point is, that is far from the ultimate measurement rig, but it's a really great way to answer a question. And I was able to get an answer to the thing I was wondering about. So it's really more than anything, it's a philosophy about what happens if I do this. The example that I always laugh about is Ethan Weiner has a great thing on his website about Ethan Weiner's made his most of his career in acoustic treatment. And so he knows diffusers and bass traps and all sorts of things at a high level, and he's great. And these ISO pads that go under your studio monitors. And he said, well, people they're supposed to absorb the vibration. They're supposed to isolate the speaker and then tighten up the response. But people also sell metal pyramids that are supposed to go under your speaker. And he's like, those are super rigid. And that's kind of the opposite. So which is it? Which is better? So he did a bunch of tests with all these different products under the speaker. And what he found is they do change the sound, but because they raise the height of the speaker. And by putting a book and an empty pizza box under the speaker that were the same height, he was able to get the same results. So yes, you are hearing a difference, but not for the reason you think. And that's a really important idea, is that, there are so many just horrifying bloodbath arguments on the internet about products like this. I'll give you one example. I like this. Do you want to learn the answer or just know the answer? Are you a person who some people just it's about how much they know, or do you actually want to find out? This is a snippet from a thread that was on the ProSound web forums. This thing, the question was something like, hey, if there's a DC current spike, and we'll put aside how do we parse that statement for a second. And you're using a mixing console that has transformers in the preamps, which is not too many these days. Will it go through the preamp? What happens to the console? And say, well, it's DC. It should be blocked by the transformer. And other people said, no, it's a spike. And so it's a high frequency event, so it should be passed. And they were getting into what Fourier analysis says and, going into the Z plane and the S plane and high level mathematics that I don't understand. And this thing went on for 3 days, at which point I went down into my basement and got a transformer and a 9-volt battery and plugged it into Audacity and see what it did. That's what happens when DC gets applied to a preamp, right? Or to a transformer. So there you go. So the people in this thread are probably all smarter than me, and some of them designed consoles and have been doing this for 40 and 50 years longer than I've been alive. But this took 3 days to not arrive at an answer, and this took 5 minutes, and now I know exactly what the answer is. It's this. So I guess my question, and I don't have an answer, is what is stopping anyone else from doing this same type of thing? And so if we're going to call ourselves audio engineers, I don't care how we choose to define that term or whether or not you have a license or if there's a governing body. In spirit, to me, it's this, as defined by Steve Centuria, who is a electrical engineering professor at MIT for a long time. He said engineering is the purposeful use of science, right? So we're using scientific principles to answer our questions. And to me, by that definition, I think we're all engineers, and it's definitely a verb. So that's just kind of a little look into how I try to approach this stuff. as Jamie mentioned before, you can reach us at these email addresses. You can also download a demo of Smaart if you don't have it. You can, I think it's 90 days right now because thanks COVID. And so you can download that and start digging into this stuff for yourself. So I think that's about all I have.
It's a funny thing that that people seem, when I first got involved with this, I made a call to a bunch of people when I was doing research. I was just a student at Yale, so I was just a graduate student in the theater at Yale, and I called around and I talked to different people. I called Don Davis up, and he was great answering stuff until he asked me the question. He said, "What measurement systems are you looking at?" And I said, TEF, and I was looking at maximally sequence stuff, and I was going through the stuff, and then as soon as I mentioned SIM, he started yelling at me. And I'm just a person. I'm just a random, college student. And he was yelling at me, and he wasn't letting me speak anymore. And he was getting agitated, and it freaked me out. One, because he was every time I've talked with him, he's been very nice since. But it was that people see they see these things as, I don't want to say as religions, but it's kind of, I'm a SIM person, I'm a TEF person, I'm a smart person, they're all tools built for a purpose. It's like saying I'm a hammer carpenter, right? But I'm not a wrench carpenter. I'm a hammer only. I'm Maslov, right? And so the thing is that these are tools, and one of the things about these tools is that they were built by people, and they made some decisions for a reason when they were building that tool. But they're like, Smaart doesn't get upset if I go and use another analyzer. It really doesn't care, and we don't care either. They are built. There are tools that are good for different things, and what's really cool is they don't cost $12,000 a pop, and so you can have all these tools, and you can ask these questions. And I just think it's funny that people go with what they know. I totally get that. I totally get that. And really that's important, because you want to be comfortable and really working on the problem, and not have your head focused on, if you're focused on your measurement system instead of what you're trying to measure, that's a distraction. So that's just something that I found that people were treating them. Hopefully it's people have a lot less respect for them now. It's like, it's something that these are tools that we use, and you use the ones that you feel comfortable and you can move quickly with. A lot of the stuff we do in Smaart isn't putting measurement power, it's putting interface power, because it's getting the data but making it usable by the person who's actually doing the decision. So it's how can we make something more powerful, but it's still trying to make it easier to use, because I think that's the key to having a good tool. So anyway, I just thought that was kind of funny that sometimes people don't want to admit that they use, I use RumiQ Wizard, I use WebSigns, that's okay. It really isn't something. It needs to be demystified, I guess, that way.
Before we get too crazy, there was some conversation when we were talking with Dan about what we were going to talk about tonight, and sort of interesting applications. Obviously, the welding ranks. My mentee Wes is here, and we were working on a project where he was asked to find out about the noise made by trains going by a venue. And so we figured out how to do that with SPL logging. And it was funny, after we figured it out, we got probably 4 more support calls within the next month from other people trying to do the same thing. So I'm old hat now. But Wes has just a few slides to show from that project, because I thought it fit very well in the spirit of we're talking about tonight. If he's still around. Wes, are you still here, buddy?
Yeah, hey everybody.
All right. So take it away, man.
Great. I'll just take a moment, but hey everyone, I'm just a mentee of Michael's, and I was hoping to share a little bit of data with you that I did when a real estate agent approached the regional production company that I work for, wanting to figure out what do we do about these damn train whistles. They're interested in building a residential development area, and what's a nuisance to some is not necessarily a nuisance to others. And newsflash, I live in a city literally called Grand Junction, which is kind of built and fabricated about trains, but that is a whole nother conversation. The meat and potatoes is my employer originally had quoted out a way of logging all of this information by just setting up a digital desk with the USB flash drive and recording 24 hours in a row, 7 days in a row, and then going back and analyzing all of that data. And I was the one that was asked to do it. It was at the beginning of the pandemic time, and I was happy to have the hours, but that sounded horrible to me, having to scrub through really, really, really long WAV files transferred off of a USB 2.0 flash drive. And I'm like, there's got to be a better way to do this shit. Pardon my language, everyone. But as you can imagine, I was like, what is a different way that we can do this? So Michael has been mentoring me for about a year now. And this is just after I had read some release notes from Smaart version 8.5's beta release, which had just launched the ability to do 24-hour logging for the SPL metric. So I'm not going to be showing samples of the software itself tonight, but I do have a couple of screen grabs in a minute that I'll share within the SPL reports that you can now generate from within their program. So I'm going to screen share here. Pardon my grandpa technology usage.
Well, one of us actually rehearsed, and it wasn't me. Very nice, Wes. Very nice.
Is everyone able to see this? Is it showing up?
Yep.
Looks
Awesome. Thank you very much. So my objectives at a quick glance were, when are these train whistles actually happening? Because if it's during, normal 9-to-5 commerce, it might not be a big deal. Context is extremely important. How often are they actually happening? Is it one train blowing its whistle a few times as it's on its way in? Or is it someone who's trying to stay awake? That's the operator. We don't really know. And an issue with the real estate agent, which I'll get to in a little bit for my takeaways, is how do we communicate how loud these things are actually happening? Because the truth is, the number really doesn't matter as much as how much the ambient noise floor is actually being raised by these train whistles. Because at the end of the day, contextually, if you're standing right next to a train station and a train whistle goes off, are you justified to be upset about the volume of the whistle? Whereas if you're perhaps indoors and a train whistle goes off and you're only used to hearing HVAC and Jerry getting a second drink from the water cooler, and then a whistle goes off, that might be perplexing to you or might be disruptive. Fast forward to when this residential development is put together, you're having your family or a romantic dinner, and then the train goes by. Sure, that might be disruptive. That is a nuisance. So we wanted to kind of look at this from a few different approaches, because at the end of the day, the real estate agent wants to go to city planning and figure out a way to have noise ordinance issues. But the reality is sometimes these things are happening overnight, etc. Some of the things I had to consider were the location that I was logging this information from. What you'll see on the next slide is 2 locations I chose to measure from. One was my fixed variable. I chose to have an indoor microphone because that was kind of representative of being within your household. And then I chose a rooftop location. I put a mic up on a roof. I wouldn't really recommend it unless you've got the right gear for it, as you'll see in a little second. But being able to see those 2 through different filters, looking at the different frequencies, specifically pertinent bands that can really help us see through the data, was much more helpful, having 2 locations to kind of juxtapose on top of one another to see where their peaks aligned of where those whistles were happening. What tools I needed to use, obviously I didn't want to use a digital console with a thumb drive because I'd be spending more time transferring those files and it would be just ridiculous. I ended up using 2 inexpensive measurement microphones I had in my kit. I chose a 2-channel IO. The Scarlett 2i2 is old faithful for a lot of us around here. And a 2010 MacBook Pro, just a little guy, but I needed to find something that I could leave on site without having my main personal rig, hopefully being used on gigs. It wasn't, newsflash, but I needed to have something I could set and forget 7 days in a row, just checking up once a day to start and stop the logs so that I could look at the data more efficiently. And then obviously I mentioned the efficiency part of it later. So let's look at some data. The top chart is going to be the outside microphone. The middle chart will be the indoor microphone. And then the bottom chart you'll see was the inside microphone, but filtered. So it's just looking at the energy that's focused on the octave center at 1K. Before I compare all of those, for those of you who aren't familiar with looking at this graph, this is going to be your dB levels here on the left. And then on the bottom right, this x-axis is going to be timestamps, parts of the day. I shot for starting and stopping these around noon. So these are just, I believe it was a Sunday into a Monday rollover. These are all from the same day, but you can notice that if you're looking outside, if you don't have a badass windscreen, you're going to be struggling with some overloading of your capsule. Hopefully not your preamp, but that's going to be a bad day. So luckily I was able to put a windscreen on the microphone, which I have a picture of in the final slide. And this is very difficult to look at a glance. If I was just using the outside microphone, which is probably the first thing that they would have spec'd, it's difficult to see all the peaks and to count how many train whistles are actually here. Luckily, shout out to, SPL within Smaart, you can really look at a whole ton of different filters, weightings, etc., time periods, you name it. And this shows them slightly offset, but that's part of the beauty of having the filtering down where the peaks are the same. So here's my fixed variable now. This is where it gets interesting. If we just look vertically above for these identical timestamps, you can see the data start to get cleaner and cleaner until ultimately, if we look at the indoor microphone filtered at the 1K octave center, you'll see 1, 2, 3, 4, 5 whistles in a 12-hour period. And just like that, I'm able to see through all of the data. It is extremely helpful to be using tools that are not necessarily meant for this, but they're meant for the fundamental idea of logging something over time. And now being able to look back and load this data into Smaart is extremely helpful. So in conclusion, let's talk about takeaways here. Something I would have done differently if I had to have done this project once again. Number one, let's look at first of all, let's look at the picture here on the right side. That is not a fancy Earthworks microphone, but it is a fancy way to try to dissipate a little bit of heat if you're going to leave your mic out in the sun for a long time. This is a basic pop filter, or windscreen rather. And another way that you can prevent any overload in your capsule and your preamp is by turning it all of the way down before calibrating that particular channel. That's just a good safe bet in general, but this is one of the ways that I avoided overload alerts that are something you can build into your logging. So the first day that I wanted to do this, let's backtrack here for a second. You can set up alarms so that when these peaks surpass a certain threshold, they'll set alarms with timestamps so you know how many times you passed X, Y, and Z level and when. But it was so arbitrary day to day that I actually had to go back and remove from the data a whole bunch of alarms because I was just surpassing it left and right, especially on the outdoor microphone being exposed to wind. I would not recommend setting up alarms unless you specifically know from an ordinance or from a building personnel what a number actually needs to be, perhaps for a concert or something like that. My takeaway for effective tools is also to not necessarily have to spend a whole ton of money on calibrators. I now own an iSemcon calibrator that's very nice. It's class 2, I believe. And that is the tool that I then used to check against the original cheapo calibrator that I had, because it's all relative. I wanted to see how far off my measurement was, because at the end of the day, I was concerned in the change of noise floor, not necessarily the overall level. I still included those in my report to the client, but at the end of the day, you want to remain that objective third party who just notices the changes and gives them all the data and lets them make the conclusions. And then thirdly, my final takeaway is this is really fun stuff to do. It was amazing to learn more about Smaart. Before I got into real-time mode and being able to do some really cool FFT stuff, I actually got involved more so on the SPL side of things, doing this project 7 days in a row. I got a lot of great reps in, but the challenge was, as I'm actively learning this content, how do I communicate it confidently and clearly with some translation to a client who at the end of the day wants to know if she can try to put some legislation or some paperwork together for the potential clients of building a residential area. This was a really challenging experience for me, but Smaart was a very powerful tool that I'd used this project on, two $50 microphones, $70 interface, and maybe a used price of maybe $300 or $400 on a laptop. It was effectively my C rig being able to put this out and get great results. I would highly recommend downloading the demo and playing around with SPL stuff, because the most recent way I used it is trying to find out how loud my neighbor's dogs bark, but that's a story for another day. That's all I have in this regard. I'll stop sharing my screen, but I wanted to say this is a really cool opportunity. Thank you very much for having me be a part of this. I'm new to live sound in particular, and it's nice to know there's a lot of people out here just like me. Are there any questions or anything that I can do to pass it off back to Michael?
Let's see. Nothing came up specifically for you, Wes, but that was awesome. Thank you so much for sharing that specific situation. We've got another gentleman here, Bob Smith, who also has an application that he uses Smaart for in real world. Are you still here, Bob?
Yes, I am. And how do I go about sharing my screen here? I don't see that it's come up for me. Oh, here we go. It just did. There we go. Are you all seeing a picture of what looks like a medical device sitting in a room that might be familiar to people who work in sound rooms?
Yep,
Yes.
looks good.
Okay, very good. All right, first off, I'm Bob Smith. I am the principal scientist at Physio Control, now Stryker Emergency Care, and created a department called the Acoustic Systems Department. And this picture, I'll spend more time talking about this picture than I will all the rest. I'll try to keep this under 15 minutes. I know it's getting late for everybody. Also, to Michael, very good, excellent concepts there about asking questions and A/B comparisons. I'm a real big fan of both of those. So that was an excellent presentation there. And in fact, that's kind of what we do in our work here as we ask questions of how effective are the sound systems of our medical devices. We use a lot of tools. Smaart's one of them, and I'm going to show some of the Smaart things. But yes, we're also familiar with Arta, Room EQ Wizard, Home, Acoustics. I've got a D-scope sitting up here just outside of reach of my hand here. All kinds of analyzers. They all do things a little differently, and they have their places where they excel at one thing, but maybe another tool is better for another job. So we use Smaart during the prototyping phase as well as for the design verification process of medical device sound systems, and we've done so for decades. These sound systems must be reliable and audible during acute events when a life is hanging in the balance. Defibrillators like this AED are typically deployed because somebody's having a cardiac arrest, and the communication has to be as near perfect as possible the first time through. You don't want to be wasting time because time is tissue. We're losing heart muscle very rapidly. And there's two types. There's the basic life support and the AEDs, like I'm going to talk about right here. And there's advanced life support, and we'll see one of those in a bit. This room has several things going on in it. We have an acoustic model for one of our AEDs that's being evaluated. And we also are in a room that's been designed to control the sound in the room. It's not an anechoic chamber, but it's also a very well-controlled space. And for Michael, you'll see back here a trap from Ethan Weiner, a corner trap back there. And there's 4 of them in the room, or maybe there's 5, I can't remember. We also have a sound system. We have these little point sources. There's 4 of them in the room from Meyer Sound, and an Electro Voice mid-sub and some bag-end really low subs. This system constitutes the surround ambient sound system that we use. We go out and make calibrated recordings of environments where our devices are deployed and used. And they're calibrated recordings so we know exactly how loud things were at the time, and can play them back in this room as nearly the same as the environments we were in before, which is why we need to control the sound space and we need to calibrate this system. Well, what do you know? When we go out and do our calibrated recordings, we assess it, we use Smaart. When we have tuned this room so that we get the playback that we want out of these this surround ambient sound simulator, we use Smaart. When we want to assess the ambient noise of the room, because we are in a space that's unfortunately in a factory, and we didn't get the raised floor we want, so things that happen on the floor below sometimes affect us. There's manufacturing equipment down there, and so we have to be aware of that. We use Smaart. And in this case, one of the principal reasons for why I want to use Smaart when I'm evaluating a prototype system is for the real-time transfer function that I can get out of this thing as I change parameters on the prototype. And I'm not just talking about EQ or anything. I'm talking about physical, mechanical parameters in the implementation, whether we're using vapor barriers, because our products have to meet an IP rating for moisture and dust, and the position of the device in the room. So here you see us using the AD in a prompt sounds, the voice prompt sound system, Spectrum and SPL, both Spectrum and SPL in this room. And I think that's enough on this one. We'll go to the next slide. Here we are. Where's my slide? There we go. And so in that previous evaluation, maybe we're at a particular sound level, and we want to know, as we approach the driver's low resonance, we're talking small drivers. These are 35 to 50 millimeter drivers, and they're usually inexpensive Mylar diaphragm drivers, so they have some peculiar characteristics. And maybe we want to know about the distortion that occurs at the low resonant frequency of the driver as it's implemented in a particular acoustic model, the enclosure. And we're going to ask questions about that. I'm not going to give you the answers here because some of this is proprietary, but I want to show you that we're using Smaart in a way to help answer questions of things that we need to know, because those lower frequencies and the distortions can get their way up into the upper ranges and interfere with speech intelligibility. And so in a differential comparison, here is a prototype that we've got on a hardwood floor, and we're evaluating it and asking, well, how different is this than if we take our prototypes and we're on carpet? It does matter. It does make a difference. And additionally, back in Smaart 5, there was this great feature called the SPL time history. And here it is. We're using it at this point in time when we're using Smaart 5 to evaluate the balance between the voice prompts. These are voice prompts. I think this one's ventilate, and these are CPR metronomes, a timing sound to help you guide you in doing compressions. And then we've got a voice prompt, and we've got to get this balance right so that the perception is that these just sound right to the person who's doing the resuscitation and not distracting. Meanwhile, we're also able to watch the spectrum as we're going through the time history. So one of the reasons we never moved 6 at this was that feature went away, and 6 wasn't, in my opinion, all that great. 7's much better. Here we are with an advanced life support system. This is a defibrillator monitor that will travel with a paramedic. And so when you call 911, he's likely to be carrying this kind of a device. And here we are set up in our same surround ambient sound simulator. And we're going to play challenging sounds, and we're going to monitor the room acoustics in various places. There's some microphones about, and we're also going to capture the sound of the device in the simulated environment and assess it. Here's a different use of the device. In this case, we're looking at the low battery alert that this AED will emit when the battery's getting low. And you don't know what orientation the device is going to take wherever it's being stored. It might be in the trunk of a car. It could be hanging on a wall. It could be on the shelf or in a desk, or in some case, depending upon how the owner is storing it. So you can see we've got a measurement mic there, a measurement mic here, a measurement mic here, and we're kind of catching all angles and then assessing what's the sound level and what sound spectrum of our low battery alert, and helping guide our designs. Now, another interesting thing that we have to do is we have to meet regulatory compliance, and the IEC is one of them. Then they have some specific regulations on speech intelligibility, in particular for AEDs. And one of their tests, IEC 60601-2-4, has a test where a person with ordinary hearing is to listen to the prompts at a distance of 1 meter from the device while being subjected to an ambient environment of 65 dB SPL of white noise. Well, one of the things we want to make sure of is that we are actually achieving in our surround ambient sound simulator 65 dB of sound level and getting a fairly even spectrum of white noise. And some of you might be asking yourselves, why white noise? Well, these regulations often get put together by people who aren't necessarily as well connected to the audio field. And I'm going to particularly point to electrical engineers who love to use white noise, which is great for circuit design and circuit analysis. And they also like to look at linear x-axes as opposed to logarithmic. So internally, what I'm not showing here is internally we test ourselves to 75 dB of pink noise. We hold ourselves to a much more stringent standard, and we will always pass the IEC test. And for the record, since they like to see third octave things, here's our third octave measurement. I mean, you can still see that we're using Smaart here. Other things that we have to do is to evaluate the noises that can be occurring in the box that aren't related towards communicating anything. And in particular, we've got a measurement microphone in our controlled space, and we're looking at a pump. The pump is used in two places. There's a CO2 monitor that has to draw air back from the patient to evaluate. And there's also a non-invasive blood pressure cuff. When you go in and get your pressure taken at the doc, they use a sphygmomanometer and a stethoscope, and they listen. Well, in our unit, it's automated, and there's a pump to pump the cuff. We need to know attributes of the spectrum and the sound level from that pump. And here's another view of that same measurement. We also have a microphone inside of many of our products, and we need to know how that microphone is picking up the sound, what its transfer function is, especially since we're going to talk about putting a vapor barrier over it. And so in here, we're going to use the Smaart transfer function to do a differential, much like the 4-mic. How are these mics performing? Are they the same as my mic broken that Michael showed you earlier? We're doing a differential here between our onboard mic and a laboratory mic. These things are as coincident as we can get them, and we're going to present them with about 75 to 85 dB of pink noise at about half a meter in front, and then ask the question, what vapor barriers, what size hole, the mounting of this microphone in behind, how do those all affect the transfer function for this onboard microphone, which is used to capture the on-scene audio of what's being said during an acute event. Another thing that we are worried about is, well, what does the spectrum look like in the environments where the patients are transported? So here we've got their microphone set up in the back of a rig that is typically used for transport of the patient by the paramedics, and the devices are going to be active in here. And so we need to know how our devices will sound in these ambient environments, and what common maskers we might be facing in these environments. And then finally, we also worry about what are the ambient residual noises. And so here we've got an ACO Pacific 7020, which is a 1-inch capsule, has a very low self noise. I think it's spec'd a little bit below 0 dB. And here's an example of using Smart here's the NC curves brought up just for a reference. And here's an SPL at a very quiet moment, about 3 a.m. in a specific space that is unfortunately located just a little too close to the two things that produce noise at that time in the morning: a ferry that's docked at the terminal and the engine is idling. That's what this bump up is here at below 63 hertz. And that was 2 miles away, and 3 miles away, an engine on the tracks idling. They never shut them off either. No cars, no vehicles, nothing else is going on. All the HVAC is shut down, everything else shut off. This is how quiet it can get, 10 dBA. And this red trace is what happens when you have set the gains as if you're going to measure, you've done your calibrations, and then you say, what happens if I replace the microphone with a 160 ohm resistor and catch my preamp residual noise to make sure that it's at least 10 dB lower than the microphone, so it's not a factor. And that is what I have for you.
Awesome.
That was just really cool. I haven't seen 5 in a while too. That was awesome.
I was going to say, Jamie, you had a question for Bob.
Well, yeah, is there anything in 5 that, particularly we're going through the feature list for 9 right now, but anything that was there that disappeared that you would like to see back?
Well, that SPL time history, but it sounds like you're already working on that, so I'll be anxious to see what that is. That was very useful for that particular thing that we were doing.
That was pretty amazing. The noise floor on that microphone. I haven't seen a microphone with a noise floor that low too. That's amazing.
Well, there's only two, the 7020 and I forget the other one from Brule & Care, which costs a bit more money and goes a few dB even lower, but allows you to make these kinds of measurements. If I were to, I didn't grab the screenshot that shows what happens over at the, this one's done in my own personal lab at the Redmond campus. When the shaker table is going downstairs, we get a fair amount of energy below 250 hertz that puts us up at about NC 45, NC 50 in our sound controlled space. A raised floor might have helped with that.
That's pretty cool. The application you got going on there. The microphone compare was brilliant. That's a great use of it.
Oh, the transfer function is one of the things we use an awful lot of, and why I can get that transfer function out of a lot of different tools, but I can't get them live. So as I can move things around and have real-time feedback of what I'm doing as I'm evaluating a prototype and saying, okay, let me just grab 3 different materials here and let me put one up, watch it, put another one up, watch it, put another one. There's in the early design phase, there's a lot of playing with what if. And then as we say, okay, I know a bit more about this, then we start capturing things and documenting them, because eventually we've got to have a design history file that shows, yes, we did do a lot of due diligence, we worked through things, but you don't want to capture and document everything. You spend most of your life documenting and very little of your life answering the questions you have asked. So that's where the Smart is much more effective at the early stages. Then as we get down more towards the, okay, for the record, we might do things like ARTA or something like that, where we do an impulse and then we analyze it 15 different ways to Sunday, or a VSLM or something like that. I was also reminded here, Matt, who also works at Physio, reminded me about the double bag ends. One of the simulations we do is a helicopter liftoff. And when we do that helicopter liftoff, the whole building shakes. It shakes enough that people who've are there for the first time and don't know what's going to happen have been known to get under their desks or go running, because it is a pretty impressive shaking. I've got a Bell, what is it? I forget the Bell model, 206, I think it is. And the liftoff is impressive. When we have people in for demonstrating the psychoacoustic designs that we do that make our sounds audible through these things, they're in there during a liftoff, and your clothing shakes on your body, the building shakes, it's impressive. And most important, all our psychoacoustic designs continue to demonstrate their efficacy during the presentation, while we can grab some other devices that we didn't design and show you how they get completely masked. You don't hear them, and that's not good. You need to be able to hear things during an acute event. If an alarm goes off or that you need to hear a particular prompt, you've got to hear that, and not the second or third time. You got to hear it right the first time, because every time you delay, that patient's probability of survival is dropping.
It's interesting that you had said, you were talking about when you're in the fooling around stage of testing things out, and I mean, there's a lot of work that's gone in over the years about making the workflow quick and is something that people can use to quickly work through an experiment, because that's the nature of the job, where you have a compressed amount of time to work through stuff. So it's very interesting. You would say that it works very well for you when you're experimenting with things and making changes and seeing the effects, and that was very much the intent. And we of course we have the impulse response mode, which has been significantly enhanced as well, and that's much more of the post process. Take the impulse response, dissect it, and all that, and so that's been really built out. But yeah, it's good to hear you say that it fits for that process, because that's not by mistake. It was really something. How do we make a tool that people can quickly use to adapt and experiment in the field? So that's great. Thanks.
That's awesome. Thanks, Bob. Yeah, that was awesome. And Jamie had your only question. We do have a few more questions for Jamie and Michael. Just a couple stragglers that I want to make sure to get in. Jamie, Mike Goodrow asked a while ago, did you ever work with Elsie?
I didn't work. I met Bear a few times. Actually, my wife Karen, first time she met, he walked into the lobby of Meyer Sound with a bronze bust of Pluto, the god, but never worked with him. But the thing is that those guys were really opinionated, and they're very strong personalities. The reason why I ended up actually working with the Grateful Dead was because I was not political, and I was they were just they had a very long history, and the people in the Meyer camp and Ultrasonic camp and Grateful Dead camp all were too close, and so I got to do it because I didn't threaten anybody. So, but we did get to meet him. I saw him once down in Australia as well, in his place in Queensland, but never worked with him.
Awesome. Thank you. Next question is for Michael. Back to your experiments. Just wanted to verify, curious how the foam earplug experiment was done. Was that the earplugs were in your ears, you ran a tone through your headphones and measured when you turned the signal down enough to disappear?
Yep, that's exactly what it was.
Great.
Yep. I mean, like, don't get me wrong, there's all sorts of ways to test hearing protection stuff in a lab, and I'm gonna have a whole book about it, and it's it's relatively complicated and uses costly equipment. But the whole point of that was, can we get some information on this without access to that stuff? So yeah, just my ears.
Awesome. Thank you. And then Mike Logson asked, how do you keep all these experiments organized to the point you're confident and not repeat them? Any tips for not getting buried in the details or getting stuck in a rat hole? Thanks.
If you've ever had to tune a concert sound system under time pressure, you learn not to get caught on the details. It's so broad strokes that it appears slapdash to an observer. If I'm still working after 15 or 20 minutes on a system, I'm probably doing stuff I shouldn't be doing. It's the 10,000 foot view. The stuff that, I like to say, if I take 5 feet back from the computer and squint a little bit, if I can still see it, I'm going to go after it. If you're going like, gee, should I go after that? Don't go after it. It's all about what's the rule, Jamie? The 80-20 rule?
Yeah. 80-20, the first 20% gets you 80% of the way there. The last 20% takes 80% of your time, but you really only get like 10% of the way there from there. It's the stuff that really matters. It's glaringly obvious. And there, oftentimes the little twiddly bits, they only matter in well, we're talking about being in an environment, a venue or something like that. We're not talking about a laboratory or in a studio where you have a very well-defined listening space. But it probably, the little tiny stuff only matters over a very small bit of space, and you're going to waste your time and other people's time fooling around with it. And I think I've wasted so much of my time doing that stuff that I always caution the people I'm teaching to just say, if it's a problem, it'll still be a problem in an hour, and it'll be much more obvious.
And I also, there's this thing that I call I think of it as the magnitude problem, and I don't mean magnitude as in a magnitude trace on an analyzer. I mean, like, how big of a problem is this problem? A lot of things are real and they're rooted in actual scientific things, but they're just not of the appropriate scale that we should be concerned about them. I'll give you an example. I saw this one the other day on a forum. Someone said, if you use like 4-stranded speaker cable instead of 2-stranded speaker cable, it could cause like a phase problem if like the 2 pairs aren't the same length. Like, yeah, there's an actual scientific principle, behind that, but you'd have to have a length difference of over 4 kilometers to cause a cancellation at 20K. So you can quickly do some back of the napkin estimation where you're just working on sheer orders of magnitude, like literally a 1 with how many zeros after it. And you can quickly arrive and say, no, this is not something I need to worry about. Or I drive my subs off of a matrix instead of an aux because then they're in phase coming out of the desk. Yeah, but the difference is, 3 samples, which is 0.4 of a degree at 100 hertz. Like, this is not why your subs don't sound good, right? So a lot of the things that people worry about that I like to kind of experiment with are real things, but are just way smaller of a factor than people think they are. So I call it the magnitude problem, where we know that it's an issue, but we don't have a good grasp of how big of an issue it really is. And that's part of it too. I focus on the big stuff.
Yeah, I think that time is an incredibly important commodity for, as soon as you're getting into like live sound and productions and stuff like that. That was drilled into me at the very beginning, that the reason why people didn't want to use some of these analyzers were that they were 8 hours worth of tuning or 6 hours worth of tuning. So time is an incredibly important commodity, and the worst part about it is you wasting your own time can often waste other people's time as well, because a lot of this stuff we're doing is collaborative. So you're in there using the space to do whatever you're doing, and while you're doing that meaningless, stupid little thing, then they're not able to do it. And there's nothing more embarrassing than to work for an hour on something and show it to somebody, and nobody can really tell the difference. It's just like, in, out, we could have been at catering.
Thank you very much. Very good.
Awesome. Thanks. Another question from Carlos Delgado. He said, my demo for SI2 expired. I uninstalled and downloaded a new trial with a secondary email address just in case, but my laptop still said the trial had expired. Is there any way to get one more go at a demo?
I DM'd him on this. I told him to contact me, but that is great confirmation of our protection, because you shouldn't be able to just uninstall and reinstall to go through it. But we have other demos that we have, like a demo we use for the class, so that if you've done exactly what he did, we have another 30-day demo. So you can just contact us, or if you're hardcore, reinstall your operating system, wipe your computer clean. That'll get you another 30 days, but I'm pretty sure that's a little too severe.
But I did that to one of my machines the other day, and I actually screwed up my licensing as a result, and Liz had to help me. So that's not foolproof.
It gets, and the software. One of the things about the full license of the software is you can release it on the computer, and then you can move it and install another computer, and then release it and move it back. But we always say that's very helpful for moving a license to another computer, but don't use it for hopping a license back and forth between computers, because eventually something is going to foul up and you won't be able to ever install it on the computer again. And so it's just like you're just playing a little bit of Russian roulette with our licensing system. So but yeah, we're all about making sure you can get access to the demo.
Awesome, thank you. And then the last question I see here is from Katie Gray. Katie, did you want to ask Michael your question? If you want to unmute, if you're still here.
Unmuting helps, doesn't it?
There you go.
So I was just curious, Michael, this sort of I work in acoustic consulting, and this question kind of comes up a lot because, we always have the lab test acoustic data, and then there's, well, how does that actually apply in the field? And a lot of times the lab data is kind of narrow to a specific situation. You start doing the calculations, you find it's not really that accurate. And I know there's a whole conversation to be had about lab test data, but I just sort of found your conversation about, just test it in the field very refreshing and very different from the usual conversations I experienced. So I was just sort of curious to know your thoughts about that.
Yeah, I mean, there are obviously some things that aren't going to work in my garage. Like someone said, I want to measure the noise floor of my power amp or of my audio interface. That requires hardware that has an even lower noise floor, and that's why you get these $50,000 rigs in controlled conditions, or measuring stuff at 5 dB SPL. There's a whole field of people that measure tiny vibrations and stuff. So lab conditions are sort of a prerequisite. If you're designing a loudspeaker, there are some things that when you have environmental noise and reflections and stuff that just doesn't work outside of a controlled environment. But I kind of can dodge that quite a bit because I don't design a loudspeaker. My job starts 1 foot in front of the grill. So I don't care how it's built. I just need to know where to aim it and where to point it and how to EQ it and all that stuff. And so the typical stuff that I interact with as part of my job, which is deploying the sound system in the space and getting it to behave, that work happens in non-lab conditions. So I have home field advantage there. I have a friend who works for Sonos, and he has to design the processing inside the speakers and design how the speakers are. Like, you can't really sit in your living room and get as much meaningful data about how that's behaving in fine detail. They have chambers and all that stuff, and Jamie and I are going to go visit when we can. But it's like anything else. It depends what you're trying to measure for and what you're trying to learn. And if I design loudspeakers, I'd have a very different answer for you. But the stuff that I tend to focus on is stuff that happens in nasty acoustic environments anyway. So I don't know if that's an answer or not.
I gotta say, there's stuff that you learn in just trying to figure it out, that is just byproducts of the process of just getting over that inertia. And let's go and try and measure this, and you'll either learn why you don't have the right conditions to measure it, why you can't isolate it, but oftentimes I always learn something useful out of the whole process of jumping in and probably come up with a way on the second try to be able to isolate what I'm looking for. It's just controlling variables, and sometimes variables that you thought were going to be a problem aren't, but you really know when you try. It's kind of interesting.
Yeah, I think the best learning is kind of by doing, if you can do it.
Yeah.
And to me, there's a little bit of mental acrobatics about. I'm not going to open this door, I promise. But there's this thing that we've all heard and read in textbooks, and it says like an underpowered amp is also dangerous to your speakers, because when you clip it, you get a square wave and the harmonics that blow your tweeter out. And I'm not going to get into whether or not that I believe that's true, but the question is, I called Ethan about that idea because some of the math doesn't quite work on it. And I was like, that's really hard to test. And he's like, no, and he just rattles off this whole, well, here's how I would test it. So that mental exercise of here's how I would test this, here's how I could approach pursuing this, that's the most valuable part to me. And oftentimes you can find a flaw in the logic just by going through that and realizing, oh, that's not going to work because of this. And being able to, I mean, the Einstein was famous for that, right? For stuff that you couldn't possibly test practically. And then 100 years later, he turns out being right and his math was right. But, being able to kind of visualize that process and think through the logistics of what am I trying to discern and how might I design an experiment that will allow me to learn that, that's a very, very valuable thing in and of itself, even if you don't actually do the experiment. Yeah,
actually, bringing that up, I've been amazed over the 20 years of this project that the 21 with Smaart, is the experiments that people have come up with. I used to work with this front of house mixer, a guy named Bagby, and this is when we were on Dave Matthews, but I had gone and started working with Smaart, and I was visiting him at front of house. And he had set up a microphone. He had a microphone at the front of house position, and he had the spectrum of the output of the console and the spectrum at the microphone on the screen. And he had taken the two spectrums and he had offset them by about 10 dB. And then in the spectrum engine, there's the ability to delay just the engine's graphing, so you can delay it. And so he had delayed the console to the microphone sitting at the mix position. And so he's watching these spectrums bounce up and down. And I'm like, Jeff, what are you doing? That's a transfer function. You have that set up. And his answer was, because sometimes, this was his little answer with the fingers. He said, sometimes this averages out the same thing as this. And I'm like, what are you talking about? So I'm not sure if you guys could see my hands when I was doing it, but in one they're in together and one they're apart. And what was he looking for? What he was figuring was, so we'd go in and we do a quick tuning, but you never know what is it that's going to be bugging you. Normally it's there are certain things that just kind of are resonant. You're setting up your sound system in these different spaces all the time, and so there's certain frequencies that just kind of ring hollow. And in the transfer function, they kind of show up, but they're right next to other things that look just the same but are not a problem. And so he's sitting there, he's listening to it, and in his mind he's going, well, what's happening is those are frequencies where energy's hanging out too long. They're just resonant events because of where we hung the speakers. And if I was an acoustical consultant, I'd go in and I'd do impulse response and filter it by frequency and figure out what frequencies are hanging out and where you're having problems and stuff like that. But you don't have the time for that. And what he had figured out is he would just watch these bounce up and down, and where he saw the frequencies where they're not bouncing up and down together, he reasoned these are the frequencies that are hanging out too long. And they're the ones that you're having timing issues. And he would put a little filter there, cut a little bit out, and this was a process that he put on top of. So we'd go through and do the tuning. So the general rough tuning is set, and it was just these tweaks to tighten down the bolts. And he came up with that just completely on his own, but it worked. It worked. He didn't even know how to do an impulse response measurement or what filtering that would be. He's just a very intuitive engineer. He's got a lot of Dave Ratnam type of that. Those are the type of guys that will figure that out. And that's something that's pretty amazing. The spinning spectrograph. There's all sorts of these cool tests that people, that's what the infinite number of monkeys is, right? You put this in the hand of an infinite number of monkeys, and somebody's going to write the works of William Shakespeare.
Next time I take an impulse response measurement, I'm going to think of that.
By the way, L'Hospital proved that an infinite number of monkeys on an infinite number of typewriters, it's not going to happen. But
awesome.
Anything?
There was one more person here. Manuel said they have a question for you, Jamie. Manuel, did you want to unmute and ask your question? I'm not sure what it is.
Yes, I just want to ask Jamie, what is his goal for 2021, and then what will be the new stuff for Russian acoustics?
Wow, that's a fantastic question, and I think that I think Michael joined us at a perfect time for us. So, I mean, we found and you'll figure out why I'm saying this, but he had joined us because we wanted to get him involved in training and online stuff, and of course the world shut down, and we've taken this opportunity to take our fundamentals class. I've been traveling for the last 10 years or more. I've been traveling about 140 days a year. Remember how I said I was going to get off the road and stay married? Yeah, that I'm still married though. She runs the company, but I'm trying for a lot of that travel. I'm teaching the fundamentals course, and there's a real desire to do level 2 training and stuff, but you can't go on to level 2 training until you get the fundamentals. And actually the fundamentals are the most important thing, is just understanding how to manipulate this tool. And so what is great is through this process, the work that we've done over this year, we've committed a lot of the fundamentals material to video. I think that we feel we want to do it over again. And we will, but I mean, it's useful material to allow us to let people all over the world take the fundamentals class, and then we can get out there doing like 2-day advanced practical, where the one thing that we're really missing is the ability to be measuring and getting ears on, and like, I love discussing imaging and the timing decisions. It's easy to time a system. The hard part is deciding what's my timing point. Once I know what my timing point is, I can find the arrivals of the different speakers and apply the delays. It's making that decision, and that one you really need to be there and be able to listen to it. So the one of our goals is to get back out there. It's just great seeing people and being maybe able to talk to them in real time and teach, but hopefully the goal is to get a lot more of the fundamental stuff out of the way, so that when we get a class together, we're not eating up 3 days of your life, we're eating up 2 days of your life. I mean, come on, 3 days in a row of 8 hours a day, so 24 hours of class time, that's brutal. And so we want to be able to focus more on us getting our hands on stuff. I've always wanted to get the Showbox Soto down there. There's a couple of spaces in each town. You're like, I want to go and use that space. But the idea, that's one of them. And the second one rhymes with 9. Actually, that it is 9. We're working on version 9, and we want to get that out. We're at the 6-year point. And one of the big things is, when you do a major version, you redo some of the fundamental code both Windows and Mac have really gone to favor their graphing systems. Instead of, we use OpenGL to do both platforms, and that's being deprecated now. So with using the native Mac graphing and the stuff on PC, I don't know what that is. Johnny knows all those answers. But the thing is that we're doing stuff with like live 32 FFT, which we're talking about 16,000 complex points that we're graphing, and so there is a bunch of underlying stuff that it's time to replumb, and there's some stuff that we can really, a bunch of stuff we've wanted to do you get to the end of a version and you ask, what am I tired of doing? What am I tired of clicking on? Why does it take me 3 clicks to get here when if I have to click this 300 times a session, then I want something to make that easier. And so that process, we're well into the dev process on 9. So if you wanted to point out 2 things we want to do, it's that I know that while Michael is tasked with working on 9, he's also champing at the bit to expand SPL as well, which is going to have to wait past where it is. Does that answer the question?
Yes, sir.
Where are you located?
I'm in Waco, Texas. Actually, I took a class with you in 2016 in Dallas, Texas.
Oh, 2016. Oh, where was that? Was that at Alfred Media or?
It was 2016 or 17. It was 17, I think. It was.
Oh no! Okay. Yep. I don't get to Dallas that much.
I forgot the company. It's a rental company. Forgot the name.
Sorry.
Yeah, but I was there. It was December 2000.
Yeah, I got snow. They canceled my flights home, so I drove to Austin after that class and crashed with my college roommate.
I forgot the name of the place. Well, yeah, and actually I did took a class with Chris Gateway.
Yep.
On the same year. Well, yeah, it's I mean, I've been following audio and learning every day, and I hope we can see again in person. And I'm enjoying the all the improvements that you have made on Smaart.
Well, thanks. I think that one of us is going to get down there sooner or later. Might be Michael. He's got to start to get circulating, and or me or. Well, I can't wait to get back out there, and I can't wait to. I thought I hated crowds, but I miss them now.
Thank you. Thanks, Manuel. That was a great question. That's kind of another training question from Bob. Will you be restarting the in-person training at Pepperdine in Malibu at some point?
We could. Why do you have a I think their last one at Pepperdine was two years ago. I think it was. We're not against it.
I popped the training at email along with the other emails in, and so they can just send emails there. And
we have a great resource, which is a gentleman named Gavin Kanan. And Gavin was the coordinator. He's an old friend of mine from Meyer, and he worked at Ultrasound as well. But he last worked at Meyer running their training programs, but is now for the last 3 years working for us running that. So if you send it to training at Rational Acoustics, he's the man. He figures out. He basically is our. He basically coordinates all this stuff, and he's top notch. He was coordinating all Myers training programs for years, and so training at Rational Acoustics, another reason to remember that.
Awesome. Thank you, Jamie, and thank you, Michael. I think Michael might be back, hopefully, for some in-depth SPL.
You really want to do that. That
would be awesome.
Yep.
Yeah. Is there anything else you guys want to add before we kind of wrap up and head into introductions? Or
no, I just got a text from my wife going, "Are you still doing this?" And I answered, "No, I'm on my way."
Okay. Well, thank you. Yeah, I'm gonna turn it back over to Dan Mortensen to kind of lead us out into the intros. And Dan, if you're ready to hop back, and just want to thank everyone for tonight. This has been just awesome. So
thanks. Everybody. Appreciate
Yeah,
it.
really. Thanks, you guys. That was wonderful. And time really doesn't have much meaning anymore when we're online here. So it's really great to get into stuff and go deep. So yeah, let's do the introductions now. So the point of this is for you to introduce yourself and tell us your connection to audio. And we don't want to hear your life story necessarily, for sure, but for sure touch on that. So let's start with Tom Sweeney. And while Tom is unmuting, Mario, I see, doesn't have a microphone. So type in the chat and I'll read that when we get to you. Tom?
Yes, I've been in audio most of my adult life, 40 years plus. I'm here in Kansas City. Kind of semi-retired from the field. Currently working at the Uptown Theater, doing some festivals this season. Looking forward to picking back up after a year of doing essentially fishing. That's what I've been doing this year. So,
what part of audio were you doing?
I'm front of house engineer.
All right. All right, cool. Thank you. Sonny Keel? Unmute yourself, please. Or not. Steve Wilkins. Where are you and what's your audio connection? Oh boy, we're striking out here so far almost. Sound, Suresh and Simeon. I also see that you don't have microphones, so feel free to type in the chat there and tell us where you are and what's going on. Rick Chin.
Good morning, sir.
Oh, you do have a microphone. Good. Sound, Suresh, go ahead.
Yeah, I'm a sound engineer. I passed out from my school, which is in India, and I'm teaching. I'm working as a. I'm assisting my students to do the project, and I'm doing that job as a sound engineer. That's it. So I want to increase my knowledge on this field. So I try to put myself in this kind of a webinar, all those things. Thanks for admitting me and kindly sending the mails to me. Thanks for that.
You're welcome. And you've been to a bunch of our meetings, and thank you for doing that. It's really an honor to have somebody coming all of this way. And at what time is it where you are right now?
It's morning 6:30 for me.
Man.
Now it is 9 o'clock.
Yeah, but 6:30 when we started.
Yeah.
So,
when we started, it's 30.
Yeah, great. Well, thank you. It's a pleasure having you. Steve Wilkins types in the thing here: no mic or camera, psychoacoustics consulting, professional musician, home studio, and music production of my music. And I know that Steve is in Seattle. And I see that Sunny Keel says, sorry, a Korean theater sound designer in New York City, theater sound professor at SUNY New Paltz as well. That's awesome. Great. Thank you for coming. Renzo Pongirelli, unmute yourself, please. Okay, Rafael Naranjo. Oh, I see Renzo typed in. Yes, thanks. Renzo, where are you and what's your audio connection? Connection to the audio world. I'll let you type in. We'll keep going here. Mike Goudreau.
Hi, yes, can you hear me?
Yep.
Okay, I am a retired sonar engineer in Seattle, Washington, and worked on hardware for submarines and sonar systems all my life, and got interested in live sound and recording. And my brother has a winery in Central Washington, and we've moved the stage from a fixed model of the Woodland Park Zoo stage to a stage, a 1947 Dodge truck. So that's the new stage at the moment. So looking forward to some live music there.
Awesome. That sounds great. Thank you. Gary Gottlieb, mute your microphone, please. Masa, are you able to talk to us? How about Marcy Sang Olan?
You know, Marcy.
Where's Marcy? Oh, here's some. I see Renzo is from Argentina.
Marcy's from Philippines.
Renzo is from Argentina. Go ahead, Jamie. Marcy's from where?
The Philippines.
Oh, cool.
Some classes, system engineer, concert sound. Yeah, he's running a bunch of classes for us and is working on being an instructor. He loves. So.
Cool. All right, Rick Chin, I skipped you apparently.
Yeah, well.
Sorry.
I'm the webmaster for the Pacific Northwest section. I'm a lifetime AES member. I've been doing this for over 50 years, this meaning audio. I've done everything from live sound to recording and circuit design. I've worked for most of the audio manufacturers in the Seattle area. We are fortunate to have several. And what have I been doing lately? Reading a lot of spy novels. Oh,
cool.
And my family all got vaccinated, and we all passed our 2-week time window. And last Saturday, I got together with my children for the first time in 14 months, and we had a meal sitting across from each other at the table without masks.
All right, congratulations.
Ordered too much food. It was delish.
All right, I'm going to recognize Mac Perkins next, but Marcy typed in the systems engineer for concert sound in the Philippines, and it's 11:52 a.m. where you are. Thanks for joining us. All right, Mac Perkins.
Hi, Mac Perkins, Whidbey Island, Washington, and mostly an X-Audio guy now. So theater lighting and sound guy for 30 odd years, and doing a lot of random things. Now we build museum displays. So there's some audio involved there.
All right, cool, thanks. Kevin McCoy, can you unmute yourself, please, and tell us your audio connection and where you are?
Yeah, hi, I'm in Minnesota, but I spend most of my life touring. I'm a Broadway theater sound mixer, and I was most recently the mixer for the Hamilton production that was in San Francisco.
Cool. What a great production. We saw it when it was in Seattle. Just incredible.
Excellent. I think it's coming back to Seattle.
All right. Cool. Thanks for joining us. Kevin McCoy. Oh, that is Kevin McCoy. Katie Gray.
Hey, I'm Katie Gray. I'm an acoustic consultant out of the Seattle area and a AES Pacific Northwest Committee member, lifelong musician, and just want to thank the presenters again. I'm more familiar with the acoustic side of measurements, so it's always great to hear a little bit more about the audio stuff.
All right, great. Thanks, Katie. Julie Correa. Did I say that right?
I'm actually using my sister's account. My name is Stephanie. I'm from Brazil. It's almost 1 a.m. here. Thank you so much for the presentation. And I'm an audio technician at theaters, mostly.
Cool. Thanks for joining us, Stephanie. Wes Stark.
Hey
Where are
everyone.
you?
Greetings from Colorado, here in the west side of it, not towards Denver. I'm a live sound technician at a regional production company. Thanks for having me tonight.
Thanks for coming and thanks for that great presentation.
My pleasure, Dan. Good to meet you folks.
Juliet Wong. Are you able to unmute?
Hello. Hi there.
Hi.
I'm Julie, and I am a part of Sound Girls, and also joined ES after a great session you guys had with Sylvia Massey, and I really appreciated that. And also, I am a musician and learned a bit through Sound Girl, live sound, recorded sound more through Omni Sound Project, which is a new collective out of Austin that has gone online since the pandemic. And also going to a few AES programs. And I'm also a musicalist, and pandemic have gone to a lot of shows around LA area, and some rooms sound really, really great all the time, no matter what show. And other rooms, it's just kind of depends on who's mixing, what band it is, but mostly good, I would say. But you know, you can tell which rooms were treated well, set up well with intent, and that the owners cared about doing that and bringing in somebody who's knowledgeable to configure a room. Fortunately, one of our best rooms, this place called the Satellite, they ripped out their stage and their lights. But even though the owner owns the building, he didn't want to hold out, and he was thinking of making a restaurant to earn a little money, and he never did. And so I'm just hoping he will set it back up and properly. It's had a few configurations over the years. And so hopefully he brings it back, because it was a really great space for local people, local bands.
All right, great. Thanks and good luck with that. And you mentioned the Sylvia Massey meeting. That was in August or July, I think. And that's online at our website. You can watch it if you haven't seen it. And she showed her incredible mic collection, which was really a great thing. Thanks for mentioning that. All right, Janie Wallach.
Yeah, I'll make it short and sweet. Janie Wallach, Seattle, Washington. When bands used to play live, I used to record them. Thank you very much.
Thanks, Janie. James Patrick Hurley. Where are you and what's your audio connection? Unmute yourself.
Oh, thank you very much. Yeah, finally, it's like working on a Yamaha desk if you're not familiar with their muting system versus the rest of the world. So, by the way, thank you very much. I'm just impressed of how many Washingtonians are here. I spent most of my professional career on Portland venues, but I've recently retired, so I live just south of Olympia, so I'm getting a little more involved in, my home state and things like that. And so here's the proof of, the pudding kind of thing. Thank you
There you
all
go.
very much. It was just an incredible. It's like doing a show with little feet when they measure every microphone's distance to the front of the stage and delay everything. It was just, just a graduate sound seminar.
Cool. Thanks for joining us. And I see that, let's see, you need to mute yourself again. There you go. I see that Marcy said that they're a AES Philippine section member. So that's cool. Jay Philippe, are you able to unmute? Okay, Gary Sanborn, are you able to unmute?
Wow. All right.
There
Yeah,
you go.
hi. I'm a live sound engineer. I work at a performing arts center at the University of Iowa. It's called Hancher Auditorium. Done it my entire career. Started in 1983. So, and I think Michael Lawrence and I are from the same hometown, Rome, New York. Is that right, Michael?
That is correct.
So I've been wanting to, I can't remember. It was one of these webinar things. I ran across Michael's name and, looked him up on LinkedIn and wow, man, Rome, New York. So just what a small world, so, great job, Michael. It's nice to get to know you a little better here, even if it was
thank
just
you very much.
through a Zoom meeting. So yeah, great webinar. Thanks everybody.
Thank you, and thanks for coming. And I see in the chat that Masa says, I'm an IP staff helping audio engineers. I'm in Japan. I will retire my company in a few years, so I'm searching for something interesting now. Well, good luck for that and with that, and thanks for joining us. Next is Gary Gottlieb, and just unmute one of your connections here.
Okay, only unmuting one of myself. I'm keeping the other one handy because my internet is a little sketchy here. So I wanted to make sure I had one or the other up.
All right.
So first off, Juliet's, I'm wearing my Sound Girls t-shirt today. How about that? So I just got it today. I love it. Anyway, I'm Gary Gottlieb. I am in Ukiah, California. I started in the business way back, Wollensack, which was back in the 60s. Although I did record a lot of friends' bands, and then I moved into the professional sector in New York, engineering, producing, left that, went up to New England, started writing a book, got my master's degree, was doing sound reinforcement up there and sound design, ended up in audio education. And I did that for many years, running the program at Webster University and a few other places. And really, since then, now I'm just sort of taking whatever little bits. I'm what I call semi-retired, taking a little bit of this here and a little bit of that there, just to keep myself interested. And as far as AES, I'm a former Eastern Region Vice President. I am currently the Vice Chair of the San Francisco section. Also the, the head of both the historical and the conference policy committees. So a little of this and a little of that keeps me busy and out of trouble. And by the way, thank you for the great presentation. This was really wonderful.
All right, thanks. Everett Moran.
Well, I missed the presentation because the power just came back on about 5 minutes ago.
Oh,
so
no.
I thought I'd see if it was still going on, but hopefully I can watch this later. I have a Rain Shadow recording in Port Townsend, Washington. It's a destination studio with block booking and lodging available.
Was there a power outage tonight, obviously?
I'm in Houston right now, heading for home tomorrow, and we had a thunderstorm that knocked out the power.
Oh, wow. All right. Well, good luck coming home. Have a good trip.
Thanks.
Ethan Carlton, unmute yourself, please. Not hearing you. I see that you're unmuted, but I'm not hearing you. Oh, that's too bad. You got a bum connection somewhere. Something isn't selected. Let me know when you're ready to come back if you can get a connection going. Douglas McKinney, can you unmute yourself, please?
Hi, I'm another instructor at the State University of New York. I'm in Potsdam at the Crane School of Music as a recording engineer and also an instructor. And I have a long association with one of the outdoor music festivals in Massachusetts.
All right, great. Ethan, you got it there? You say you're doing it or something. Maybe not. Dave Tosti Lane.
Hold on. There we go. Hi, Dave Tosti Lane. I'm a retired theater sound designer and educator, and a lifetime member of AES, member of the Pacific Northwest Committee. Good to see you, Jamie. This is a great presentation.
Good to see you, Dave.
Yeah, definitely. So Ethan is going to just do the chat. So just type in what you want to say, Ethan, and we'll read it to you. Read it to the group. Carlos Delgado. I see that you're unmuted. I'm not hearing you either.
Check.
There you go.
Okay, fantastic. Hello, everybody. Carlos Delgado here at Malik Terrace, aka North Seattle. This is my first time engaging in a Pacific Northwest AES chapter, which is awesome. I actually had no idea these things were happening, so very happy to be here. I've done everything from being a box pusher to an uprigger, but it hasn't been till about 5 years ago that I really discovered what I want to do is audio. What really interests me right now is system tech. So Smaart is still unfortunately kind of blurry to me, but it's definitely something that I feel in time I'll get. So yeah, cheers. Glad to be here.
Great, thank you. And just FYI, I can see that your camera was not working, but you had it so that it was unmuted. So you might want to look into that at some point.
I shall. Thank you.
Bill.
Sorry, one last thing. I also listen to the Signal to Noise podcast all the time, which Michael is a part of. Anybody who is not aware or hasn't checked it out yet should really do it. It's one of the best podcasts out there regarding audio. Cheers.
Cool, thank you. Bill Santos. Unmute yourself, please. Not happening, I guess. BDO, you've been here the whole time, but I don't know a name. Are you able to unmute yourself? Nope. Okay, Angelo Williams.
Hi, hello, how are you?
Hi, good, how are you?
Good, Angelo Williams from Vancouver, British Columbia. I'm currently a church audio technician, just retired on May 1st and standing by for the next steps.
Congratulations.
Thank you.
Thanks for joining us.
Always a pleasure.
All right, Steve Turnage.
Good evening. That was a great meeting. I'm so glad that we're able to keep our quality so high. I started the drafting department at RAIN in 1986, so that RA27 data sheet I designed. So it was funny to see that in there. Anyway, so I'm a mastering engineer and circuit board designer. I do a lot of Pigtronics guitar pedals these days and a lot of mastering and author, and been involved with the section for a long time, and I'm very proud of it and for what's happening with it. So have a great night. Thanks.
Cool, thanks, Steve. Pablo Serrano, I'm going to call on you next, but first I'm going to say you joined us late, I think, and we're having everybody introduce themselves and tell us what their audio connection is. And I'm going to read Ethan Carlton's in the meantime. It says, hey, everyone, I've been doing theater sound for about 6 years, worked as FOH engineer and sound supervisor for a regional theater in Long Island, New York. These days I live in Portland, Oregon, currently studying for a CTS certificate and thinking about my next steps. All right, well, good luck to you. Pablo, are you able to join us here? Unmute. There you go.
Yes.
Good.
Are you hearing?
Yep.
Good night, everybody. I'm Pablo Serrano from Brazil, south of Brazil here. It's quite late here, but that's okay. I have a startup here. We are developing, let's say, um, educational website to teach people about acoustics and audio and so on. And now we have around 1,000 students, and very happy to be here with you guys. Thank you very much.
Cool. Thank you. Thank you for joining us. Did you just join us for the first time a few minutes ago, or were you in and out?
No, I have just joined.
Oh, golly, you missed a great presentation. We recorded it and it'll be on our website. Are you familiar with our website? www.aes.org/sections/PNW. And we'll have a meeting summary, and then the link to the video will be in our archives there. So hope you'll enjoy it then. All right, thank you. Jess Berg, where are you?
Hello, everyone. I am currently in Bellingham, Washington, and a PNW section member. As of a couple years ago, primarily live sound engineer for the past 17 years, cut my teeth in the jazz clubs of Minneapolis, moved to LA about 8 years ago to toured the world, mostly front of house, done some monitors, got into tour management, production management, and done some studio and broadcast stuff. Just really happy to be here. Tonight was awesome. I can't wait to get my hands on Smaart, and just want to thank everyone for being here. So thanks.
Thank you for your great job moderating that. All right, Gary Louie.
I'm Gary Louie. My main job's at the University of Washington School of Music in Seattle, and I'm the recording guy. And now in pandemic, you do anything they want, video editing, whatever. And mind went blank, getting old. I'm the secretary of the AES Pacific Northwest section, and I am a life member, and I'm the chair of the Tellers Committee for the AES. And I would remind all AES members that the international elections will be starting next Friday, and you should be getting a reminder in your AES emails probably next week. And then you've got 40 days to actually vote till the beginning of July. Thank you.
Cool. Thanks, Gary. And thanks for all you do for our section. Greg Dixon.
Hey, everybody. I'm Greg. I am the section chair of the Pacific Northwest section, and I currently work as an audio educator at a university that's nearby called DigiPen Institute of Technology, and I specialize in recording and composition and sound design. In particular, my interests are in interactive sound and video games. So I'm really glad that you could all be here. Thanks.
All right, thanks, Greg. And before I introduce myself, did I miss anybody? Speak up now, please.
Jamie.
Okay, Jamie, go ahead.
I'm a user. No, this is great. It's great to see this type of interest. You're the geeks that are sitting up in the hotel room loading firmware and drinking a beer with your friends. So this is my people. So it's great to hear it. And by the way, Gary, you got the best sounding mic. The connection, whatever you're recorded with right there, it sounds super clean on my end. So I think
which Gary?
Louis.
Oh.
Yeah, tell them about your rig. It's pretty cool.
Ordinary iMac, but my interface is a Sound Devices MixPre 10.2, and the microphone is a Neumann KM140. Damn well better sound good.
It does.
Yeah. Any questions?
Well, this is great. Hopefully that we can also get it set so you guys can get Michael there to go through his SPL thing because it's really fun. So thank you. This was a lot of fun.
Yeah, thank you. And finally, I'll introduce myself. I'm Dan Mortensen. I theoretically do live sound for concerts and other live events. My last actual PA gig musical was February 29th of 2020. And I've got some coming up this summer, I hope. But it's been a fairly grim year other than for PA stuff. But here I am, still here. So that's good. And I'm on the committee of the section and have enjoyed doing that for a long time. So isn't that fun to hear what everybody does? I just love hearing the variety of people who come to our meetings and have always come to our meetings. It's always something that you don't expect relating to audio. And I like that. So I'm going to turn it back over to Greg. Thank you.
All right, thank you. And I'd like to once again thanks Dan so much for coordinating and organizing this meeting. I'd like to thank Michael and Jamie for their excellent presentations tonight. I'd also like to thank the officers and the committee members of the Pacific Northwest AES who help me constantly with the organization and execution of these meetings. And I'd like to conclude by thanking all of you so much for joining us this evening. I'm so glad that you could each be here, and I hope that you have a wonderful day or evening, depending on what time zone that you're at, and that you also stay safe and healthy and well. And we'll see you next time. The next meeting is June 16th at the same time, 6 p.m. Pacific Daylight Time. I hope that you'll join us. It's going to be another excellent meeting next month, June 16th. So please join us.
You want to say what it is?
Yes, once again, it's going to be a meeting with Immersion Networks, which is a local, they are a local company that specializes in cutting edge new technologies. Steve Turnage, is he still here?
Sure.
Steve, can you maybe say a few words? He understands a lot more than I do.
I'd be happy to. I've been under NDA for 5 years, and now it's so exciting to be able to be out from under it. Because now they're actually shipping. So they've got the spatial audio mixing platform that's done in the cloud. And so it's just in a Chrome window, you have the interface, and then all the heavy lifting's done with cloud computing. It comes back to a stereo headphone mix of spatial audio, and you upload your own files. It turns them into little icons on the screen. You can move them around. They move around in your space. It's amazing. It's a game changer completely as far as I'm concerned. I'm a little too excited about it, and I'm glad it's coming out. We'll be able to see all about it on the 16th, and it's going to be released as a subscription service. And it's like someplace around $10 a month or something. And anyway, I have a lot of opinions about it that I don't really want to sully the waters with now, but it excites me more than anything that I've been involved with in a long time. I've been playing with the tool. I'm a beta tester for the tool, and from working it, I get full mixes in less than 15 minutes that are outstanding. And I go back to mastering, and it feels like I'm putting on lead boots to go back to the whole precision thing. Everything that exists still exists, but this new method of working with things, it's like placing the musicians in a room, and they're just there in the room, and you put them there, and that's the mix. And you have level of it's put into, you have direct and indirect sound, and you have choices of what room they're in: New York live room, or a plate, or a LA live room, or a default, a neutral room. And then you have direct sound and reflected sound for each, and you have placement of where they are going to go in relationship to where the headphones are. And I've been it's been crazy. It's completely changed. It's beyond, it's very cool. Makes me excited. So there's a little taste, and I'm happy to show anybody if people want to get in touch. So is that good?
The website is immersion.net, and it's up and online, and you can go explore there. There's not a lot to see. I'll have the website for the June meeting up in a couple of days. Just waiting on some last things to fall into place.
Yeah, it's insane. So when we see it, it's hard to describe how big of a difference it makes in things. So thanks.
Yeah, thank you, Steve. I really appreciate that. And yeah, it's going to be great. I hope to see you all again next month. And thanks again.
Bye, everybody.
Audio.
Bye. See you next time.